This talk, i.e. there are a lot of GIFs, so if you're at all sensitive to that, maybe step out. If not, I think it should be some fun. So with that out of the way, hi, how's it going? I'm Charlie. I like to think of myself as some sort of fighting lobster on the internet, but I am a senior director of engineering at GoDaddy. You can find me on the internet pretty easily. I'm also on the board of the OdessaJS Foundation, which was formerly the Node Foundation. I've been doing Node, I guess, now for about 10 years. So 10 years of Node.js experience, check. So you see that there, UX platform. You probably have a face that sort of looks like this. What is it? What does it mean? So I'll just sort of jump in pretty quickly. We have a lot of engineers at GoDaddy. So there are about 500 engineers that use the front-end tooling that my team builds. And they need a way to navigate it, to think about it, and to serve a consistent experience to customers. So another way to think about it is that it's the cross-cutting user interface technology. It's just a little bit more than the design system, so it includes things like shared wayfinding. If you use something like Gmail or Google Docs, it's something very similar. There's a header that lives at the top. We have something very similar. So let's talk about the design system. It's called UX Core 2, and it's about 50 or so React components. It's React-based, obviously. It's been going for almost 4 years now. It has a lot of contributors from throughout GoDaddy. That was something we focused on very, very early, was getting the rest of the product engineering group to make contributions to it. So if you find a bug in the dropdown, that shouldn't be our job, that should be the engineers on the product team's job. So what does this mean? Obviously, it's a lot of like broad generalization. So let's break down the problem. We are delivering flexible design systems, and the word choice there is very, very intentional. So let's talk about what design systems are. There are a bunch of different elements of a good design system. Who here has heard of atomic design? So I think there's an opportunity for this metaphor to be below atomic design, right? You have atoms, but inside of atoms there are neutrons and protons and those sorts of things. So they don't really talk about this in that metaphor, but I think it's really important. Like your color palette, for example, that's not really an atom, that's a subatomic thing. Your typography spacing, those sorts of things. The voice that you want to use in your technical writing. And then on top of that, you have just a ton of components. Just lots and lots of components. And in the atomic design metaphor, these are, of course, the atoms and molecules. And then something that often gets overlooked in design systems is documentation. So you'll see something like this, and then it gets turned into something like that. So you really need living documentation that gets kept up to date for all of your disciplines, not just for the engineers. So by that I mean the designers, the technical writers, and just other contributors out there, like, for example, product management. So that's what this site that I showed earlier is. It's the entire documentation site for all of the components. Consider even something like a button component that's like super simple, very obvious. We've all used buttons before. There's some developer documentation that looks like this, but then there's some very detailed designer documentation that looks like this. Like, when do I use this color button? What does it mean in the broader system? And I like to fall back to sort of a principle or philosophical idea that I learned in grad school many years ago, which is that intuitive equals familiar. So anything people talk about design or think like that, oh, it's intuitive, often the most intuitive thing is just what you've seen before. And the same goes for developers and developer workflows. The workflows being really, really important. How do you ship a change to your product? How do you make sure that when you make a change in the design system, that product gets updated, they don't have to do a lot of work. And lastly, there's a bunch of really boring things, especially at a big company, around governance. So if you had product managers compete over what feature is right, you sort of know where I'm going with this. And anytime somebody comes in and they say, hey, I've got this great feature that I want to ship into the system, you have to say, well, is that really necessary in the system? Or is that just something that your product needs to do, and you should do that separately from the system? So that's design systems. let's talk a little bit about flexibility. So first off, we've all doing responsive design, right? That's just like not an option anymore. Great, just bring that one up. But now when you think about flexibility, it's not just flexibility on a single platform, it's flexibility across multiple platforms. So this is an example of our dropdown. We can see here on web, it's working like you would expect it to work on native. And the really interesting thing about this is that when we started building the native dropdown, we just decided that this was a better experience on mobile web. So we backported the design from React Native to web, because it was just better. Similarly, when you start to think about features in desktop, certain teams in certain desktop scenarios don't want this behavior. They still want a traditional dropdown, and that's okay, but there are only certain use cases for it, and unfortunately, like this on the right here is possible. It shouldn't happen, because when they switch over there, when they see their viewport is smaller than desktop, they should turn off that property. But they don't always do that, so we should catch and look for that. So you're gonna get asked to make a lot of features. And how many features is too many? I can't tell you that, but you're gonna get a lot of feature requests. The next one that might have you sort of doing this throughout building things is styles. I think that's a very common thing that's discussed today is, should you have CSS? Should you have inline styles? What about if you need both? There are plenty of scenarios where inline styles are better, or actual proper class names and separate CSS files are better, and there really isn't a one-size-fits-all solution. Lastly, are you really a single brand? So when you think about design systems, about the embodiment of a single brand, at GoDaddy we're dozens of brands. So there's dark colors. This is, you might be familiar with Media Temple, maybe not. Some people are. This is a German company called Domain Factory. And there's dozens and dozens of these choices. So we also have like 17,000 reseller customers that they can choose their own color palette. So we support, I think it's something like 700 different brand variations in the system. And that has a lot of implications for the types of things we have to do versus you're building out, say, I don't know, Vodafone's design system or a single brand's design system. You can make very poignant and flexible choices. For example, the lambda calculus of color selection. So going back to our example earlier with our buttons. So buttons are given a design prompt. So say, hey, I want a button, its design is primary or its design is secondary. And originally this was designed to map to the color choices on the sass you can see on the left there. But what happens when a brand wants to map their quote-unquote primary button to a secondary palette color or a different palette color? This is just pure lambda calculus. But people don't think about this that way. They think about it as, oh, it's just sass, it's just styles, we can get out of the way. So just a small call out of some of the really nuanced things you can see when you're supporting lots and lots of different brands. So let's get to the meat of our content here, which is that we're going to talk about delivery. And of course not pizzas, we're talking about delivering software, which for me anyway, I end up feeling like this most of the time. But there are some very distinct phases of this. You're going to develop, you're going to publish your package, you're going to promote that through one or more environments, you're eventually going to hit production, and then once you're in production, you have to maintain that software. So I'm going to go through these sort of in order for a little while and talk about different facets of it. So when you're developing, of course, you're furiously typing on your keyboard, and this is where the workflow really is king. And it's important to remember that these workflows are shared across your team. I don't know how big your teams are, 5 people, 10 people, 20 people. But these things that you're doing need to be really easy for you to do with other people. So when you get these new contributors, you need to think about how is it going to be easy for them. Like, okay, this is easy for me because I've done it 100 times, but what if you've never done this before? What if you don't know where the any key is? One of the philosophies that have been helpful for me to make this work is that if you treat every entry point as though it could be a first interaction, that you've never seen something before, then you can usually catch most of these edge cases and fix them before they're big problems. Typically in JavaScript land, this means small modules, so shrinking things down, making them small and understandable, because these are easy to understand. Each of the components in our design system are individual NPM packages, they're individual Git repositories, because when you find that bug in, say, a button or a dropdown, you need to say, oh, this is the smallest piece of code that I need to understand to fix that bug. This is, I think, against the trend today, which is that most people take all of their tiny little modules and they turn them into a monorepo of some sorts. And I'm not opposed to monorepos, they're certainly useful in a lot of scenarios, but they require a lot of diligence. So if you go into any of the really large monorepo projects that are out there in open source land, a lot of them don't even have a good README for all of their packages. And so when you do npm home, that package, there's just nothing. There's just a blank page, the package.json doesn't know where to go, so you're just like, I don't know where this code lives or where it came from, so it's just not useful anymore. Of course, there are many other tools in the development process that you may or not be using. When it comes to preview and those sorts of things, I would highly recommend using something like Storybook. Seriously, it just works really well. I've been very impressed with it. Their native support in Storybook 5 has also been very significantly improved. But Storybook isn't always enough. There are a lot of sort of boilerplate bits of code that can get repeated over and over again. So having some kind of example structure really helps make that easier. So what do I mean by example structure? So this is very simple, basic Storybook usage. We have a button, we're going to write some stories, but this is all designed to live in a single file. And now you imagine that with like 25 or 50 examples. It becomes very untenable very, very quickly. People don't know where to find the example they're looking for, it's difficult to navigate. So how can we do something that's better? There is some pretty simple boilerplate that a lot of people use in their Storybook, which is to load some things that are called stories.js files. But these, similar to having your test files and your code files live side by side, can be pretty confusing. But it starts to get the right kind of example. That this example is copy and paste ready. I can say, hey, here's an example, go take this, put this in your code, and it just works. So you want it to be as simple as possible with a bunch of different things. Clear import usage, platform-specific examples, design documentation. There are some other things out there that are doing this, like DocZ, you've seen it. It's solving similar challenges. But Storybook continues to have that really versatile, almost Leatherman-like set of features, which is that it's development focused, it is more flexible, but it's not quite a full solution. So what would help augment it? Consider this structure. You have something that is your examples, you have anything that runs cross-platform, anything inside a web directory can actually be only run on web, similarly for native. Then, of course, you need something to alias, right? If you've ever looked at a bunch of stories, let's see if I can go back and see here. So you'll notice here that the import is relative, right? That import ... components button, that's relative, and that's a problem, because what's the real package name for that? I don't know. So that's why you need some kind of aliasing for Webpack to say, when you see this particular component, load the local version of it. That's how you enable local development. So we wrote something, it's out there. You can think of it as shared Storybook config. You can install it, you can go look at it. There are some plans for the future, and of course my dark gifts aren't showing up super well, but a bunch of the things we're working on right now involve using a new feature in Storybook 5 called presets. Supporting design docs natively, so MDX, if you're familiar with that. Also including all of your prop type documentation, and looking to support multiple tools. So one of the really big problems for people that are using DocZ is that most of the components that they're working with already have stories. So how do you take those stories and make a site out of them? So this is trying to be a glue between multiple tools to make that easier. So you've gone out and you've said, okay, we can hit the presses, we can go and we can publish our package. what could possibly go wrong, of course? So you're out there, you hit the start button, and the problem is that most people don't realize when they're writing these components that production begins at publish. There are a bunch of things that you can do once you publish the package and you break your consumers. All of your hopes and your dreams about being reliable, they get squashed. Publishing will break a bunch of things, specifically your npm install and unit tests. So if you have a set of developers, 10 or more, or 50 or more, in our case, 500 or more, and you break their unit tests, they're going to be very cross with you. And so you need to tell them that you're going to expecting to break their unit tests. We had something the other week where we're breaking unit tests intentionally for upgrading to the latest version of React's context API that shipped in 16.3. There's no way to do that without breaking your unit tests. It doesn't break production, but it did break your unit tests. Plus, there are a bunch of people that might not even be using what you're doing correctly. And so you're going to break their horrible hack that you wish they didn't do, but they did anyway. So there are a bunch of different ways to solve this problem. One of them is to have a really strict build set to try and say, look, these are the things that I want in Node, right? So you're shipping your transpiled code, and then for anything that supports ES imports, right? If you're using Node with the experimental modules flag, you can have the module code in there. And then lastly, because of the way that React Native works, it's also expecting import-based code. So you have to give it its own special version. So, of course, if you have more questions about this, I'll be at the speaker lounge after this. So then you've published your package, and now you want to go and promote it into various environments. Now, who at their work today practices continuous deployment for their product code? Reasonable number of hands. I expected more, but okay. Design systems and continuous deployment are just incredibly difficult, especially the way that we deploy them, which I'll talk about in a minute, why that's important. Because someone could be using something that you've written in a completely incorrect way. They could have hacked it, they could have overridden your CSS, they could have completely ripped inside the component and broken the API contract. But if you're doing this at a production scale, you have to support that risk. You have to just say, okay, well, they're going to go and do that, so therefore there are simply too many unknowns to this process, and we just have to wait. I don't know if this applies to a small scale, but I do know that it applies to a big scale. And how we solve this problem is we just leave things in dev and test for like a day. So we promote into dev and test, and then because we are so essential to what these engineers are doing every day, if there's a break, we broke their unit test, like we hear about it like that in Slack within 10, 15 minutes. So you've got your component, you've published it, you've rolled it out into your test environment, and now it's time to go roll out into production. So let's go out into production. This, of course, leads to many, many scenarios that end up looking like this. You make a very small change that you don't think is going to have any impact, and then all of a sudden everything is fallen over. So your bundles, meaning the bundles that your consumers create, should not include your design system or your dependencies. To put this in another way, you need to bundle up out there and use a vendor bundle. So there's some app, right? Their application. But their application shouldn't include your design system, right? And your design system shouldn't include React. So you have these three different files that get loaded. So you don't have multiple versions of React on the page. You don't have multiple versions of your button on the page. So just a small call out there. We'll talk a little more about bundling as we go on. Another way to think about this is that there should really only be one true version of your design system at any time. So what do I mean by that? So you're at your computer and you're going to publish your design system to something like npm, and then you have all of your users, and they're going to install any version they want. So these aren't web browsers, these are other servers that have decided to install your package. So that means your users, your consumers, they're all going to get different versions of your design system. And so that means if somebody finds that bug in a dropdown or a button, how are you going to fix it everywhere? You have to wait for all of those people to deploy. And when I explain this to people, they generally feel the way I feel, which is, we're just not going to do that. That's just not going to happen. So you have to enforce this consistent delivery, or you're going to face peril. So what does that mean? It means centralized deployment of your design system. And what are those benefits? There are a few. First of all, as I mentioned, you can fix your bugs faster across sites. You can roll back any breaks quickly. You can easily rebrand your system. So one of the things that we tout as a very central value add to what we do at GoDaddy is that if the brand or the company decides that they want to change the look and feel, we can roll that out to every site worldwide in under an hour. And we've done that a few times in my tenure. You also get better insights into your usage because you'll see who's downloading what version of your design system. You can include instrumentation code to see who's using what, which lets you decide how you want to do bundle splitting. So I'm sure I've piqued your interest. You're very interested in learning more, and how do you do it? Glad you asked. First of all, you want to separate out what I was talking about before, right, into those different bundles. And the way to do that is using Webpack externals. And you want to expose those in a versioned NPM package. So if you don't know Webpack, maybe, who knows Webpack? Okay, good. How many people really know Webpack though? Like, do you know what it is? Or you know, okay, that's what I thought. Nobody really knows Webpack. Most people, when they hear about Webpack, they just make this face. Just no idea. Like, I know it's important, but I don't know how it works. So what are Webpack externals? Let's look at that for a second. So any Webpack bundle is essentially two parts. There is the module loader, the factory. It's a bit of code you'll see at the top of pretty much every Webpack bundle. And then there's an array of modules. Each one of those modules is the code to the actual module. So module 1 code, module 2 code, these are all wrapped in functions. So when you externalize something, you still get that block of code, but instead of it being the real code, it is a path to something that already exists on the window. So the other bundle, previously like that react.min.js bundle, they're setting window.react. And in your design system is setting window.designsystem.button. And all this is doing is mapping between them. So there's a very specific way to externalize things. This is config that I'll never understand all of it. I think I mostly understand it, but it's supporting AMD, UMD, along with node style require, and the other style of node style require, CommonJS and CommonJS 2. I still don't quite understand the difference between. But it's saying that when you're looking for this component, it encounters the require, go look for this particular thing that's on the window and use that instead. So what does it mean to externalize this? You would ship this in a package, like your system Webpack config. And then anyone that's consuming your system is going to require it and use its externals. So it's this yellow block right here. So now you're versioning your externals. So when you say add a new component to your design system, it's going to automatically get externalized the next time people install things. So now you've got a way to externalize things, but how do you actually get the content out there? How do you make sure that everyone's using the same script and link tags for your design systems? In other words, how do you ensure consistent asset distribution? So you're back at your computer. You're going to publish your design system. And on the other side, you have all of your users. And you need them all to have the same version of the file. So you could publish some kind of intermediary, and then they go out and they request what version they should be including every 10 minutes, 15 minutes. And this is what we do at GoDaddy. Well, there's an open source system that we wrote to do this called Warehouse. And then everyone gets the same version. Because every 15 minutes, every server in your whole company goes out and says, hey, what's the latest version of the design system? What's the file that I should be including on my page? And this is great for a bunch of reasons. But it's also got its downside. Because you want the gold, but you don't want horrible skipping. And there are a bunch of ways that this can fail. So when you're removing externals, that can be really dangerous. When you're renaming externals, you need to sometimes do a little bit of massaging. Ensuring that people are using it correctly, also dangerous, but nothing nothing you can do about that. And of course, there are the unexpected consequences, the places where they're hacking what you're doing, and you have to roll back. You have to do something about it. Like you rolled out, there's been an unexpected break, and ideally, you want to go and just get rid of the entire problem altogether, but you can't. You have to actually have a real rollback plan. So some of the things that we've done in Warehouse to make this easy, so that you can be some sort of happy cat at your computer, is that it's all based on NPM. So you would just distag the prior version at production. You can try this out. It does require a bit of setup. If you've ever used Cassandra, that's the database that's behind it. But we're working on moving it to DynamoDB, which should make it sort of a lot easier to install sometime towards the end of the year. So now you've got everything out there. You have the first version of production, and you have to maintain things, making sure that fires don't happen, and when they do happen, you don't end up feeling like this. You're there, you're excited, waiting for it, and then everything goes wrong. Which is, of course, DevOps, when things don't go as planned. So we remember our example here. We have our great setup, but that went down for some reason. And now, all the next requests are going to fail. And now, everyone is down. And the people who hired you are screaming like this at you because you've introduced a single point of failure into the system. And there are ways to mitigate this, but in order to do that, we need to talk about a really scary thing that nobody likes to talk about, which is caching. So there are really two types of caching, and it's really, really important not to conflate them. The first one that most people are familiar with is performance caching, and that is saving copies for speed. So same thing as before. Let's say that the request to get the files is 80 milliseconds. That means if you did this every time, you'd be adding 80 milliseconds to every one of your requests. But when you always use a cached copy, then it's 0 milliseconds. There's you only pay for that cost the first time. But the more important one, the one that'll solve it for you here, is saving copies for later, which is failover caching. So this content, right, your design system, is highly cacheable. If in the event of downtime, somebody's using your design system from 2 weeks ago, it's fine, right? Like you're, oh God, you have last week's button, like it's fine. So to do that, you want to have some kind of disk caching in place. So you have some unexpected downtime, but when they use the failover cache, which is on disk, it's in their container, they have it, then everybody's still up. It does halt deployments, right? You can't do a new deployment, or if you do a new deployment, you have to make sure that that part of your file system is safe, it's not overwritten on deployments, but you've mitigated the single point of failure. Over the last year, we've had like 9 minutes of downtime in that system. So it needs to be highly reliable in the first place, but you've got to have this other level of ensuring that people cache your responses, because it's okay to use the old version when there's unexpected downtime. This is also referred to as, I forget the word, it'll come to me later. Anyway, so to do this, to do the impossible thing, not really that impossible, but to do that, this is why we created a reusable out-of-band cache. So you're writing any sort of API client, you want to do this out-of-band, meaning that you go and you get the version of your design system, but then you're going to use the cached version, and then out of band, it's actually going to go and get the next version. You don't want to wait for that cache to expire, you want to refresh it without blocking the user. So this is incredibly simple to use. So this is a very simple example using fetch. So we've set up the max age cache items for 10 minutes, still serve the expired cache for 1 hour, and also disk cache. So we're going to save these responses into a .cache directory on our file system, so that if we fail over, we will use those files as the responses. Then we're going to get some URL, meaning the URL to your design system, and we're going to use that as the cache key, because that's probably the easiest way to represent it. You could SHA or hash it in some way. And then we're just going to fetch it. And to do that, we're going to use cross-fetch. And then we're just going to put that JSON, give it back, and throw it to disk. So, getting towards the end here, there are a couple more things to think about. How do you keep your car nice and shiny? Hygiene, i.e. paying technical debt. And I always talk about this towards the end here because most of the times when I talk to people about tech debt, they look at me and they have this face like, nope, we can avoid it, we can deal with it. Nope, you can't avoid it. On a long enough timeline, it will take down your systems, it'll cripple any software project. Not front end, not back end, just any software project will fall under the weight of its own technical debt if you don't address it regularly. And if that sort of makes you feel like this, like you don't know what I'm talking about, upgrading to new versions of React or Babel, how many people really enjoyed the upgrade to Babel 7? Yeah, it takes a lot of work. It was necessary, you had to do it, but it was a lot of work. Upgrading to the newest version of Webpack, always pain in the butt, but you gotta do it. Removing deprecated APIs, this is the current, I think, tech debt for people that's gonna be for React 17 is component will receive props and a couple other ones. Also the latest APIs, so you have a tooltip component that was written before React portals were released, so it's probably better to rewrite it with portals or upgrade everything to the React 16 context. These things, if left unchecked, are really going to have a huge impact on the usability of your design system for your engineers. But if you can handle all that and avoid the pain of this, then you'll be pretty good. And hope it works out for you. These will all be up on the internet pretty soon. And thanks for listening.
Great, thanks for great talk. So basically we have like 5 minutes in timing, so probably we can ask 2 questions and after that you could find Charlie on Speaker's Corner on feedbacks. Do you have somebody questions? Yep.
Hi, thanks for the talk. My question is, how do you ship your styles? You don't bundle them with Webpack?
So we do. We ship a CSS include. So the warehouse responsible, it includes just a set of files. So it'll include like the JS file and the CSS file. So we, in the Webpack terms, we have 2 different entries. So there's like a Webpack config for the JavaScript and a Webpack config for the CSS. But you can do it a bunch of different ways. Right, yeah, we have a top level CSS include and then like an index.css and an index.js. We don't, like a lot of people import their CSS in the JavaScript, we don't do that.
Hi. I'd like to know, I see this change coming in our company now with React moving to the new hook API, and I was wondering how you handle it in your case. Like, you assign one developer to do it, or do you spread it out to everybody?
So paying technical debt, like if you have a big enough team, you can generally just sort of spread it out. Like the classic example I like to use is that we upgraded very slowly to Flexbox over 18 months because most of our CSS, like with the exception of the grid, the stuff where they were using our classes that were Flexbox based, it was encapsulated. It didn't matter if we were Flexbox or float based. You were just using a button, you were using a drop down. And so we could do that very slowly over time without having to say, okay, we have to stop all product development or all new features and pay the debt. It's like I think of it like a tax. Like every sprint, there's a tax. Like 10%, 15% is technical debt. And if you are really forceful with other managers of your backlog, then you're always doing a little bit of debt pay down and it'll never crush your team.
One more?
Thanks for the talk. I actually have 2-part question. First, do you do any screenshot testing of components when you migrate from one version to another, just to see the visual consistency? And the second is about how do you keep the actual design system consistent, so everybody in the student all stakeholders how to use it.
So
Thank you.
the first part about visual diffing, we don't do that, but that's something we're really interested in doing. We're looking at Webhit for doing that, which is another OpenJS project. And on the second point about making sure people understand the changes, we have some internal DevRels, developer relations people, that when there's a big enough change design-wise, they'll send an email out to a set of stakeholders. We have Slack channels where we say, hey, this change is coming, just so you know, like, hey, now the change is out. And we've learned over time that it's, let them know that the change is coming, and then when the change goes to dev, then tell them again that the change happened, because that's the day where they'll say, oh, this looks weird, and it's that day, that's the day that they'll go to the Slack channel and say, oh, okay, they just changed it, that's fine, that's intentional. And then you do another notice when you're in prod, but at that point, most of the developers already know that it's coming. They're like, oh yeah, I know that change, and then they're going to tell the other stakeholders on the notice in prod, like the engineering manager, the UX person notices in prod. It's like, oh, that's by design. You can go talk to their designers about it. Cool. Thanks, everybody.
Yep. Speaker's corner. If you have some other questions, please find Charlie. And thank you again, Charlie. Great talk. Сейчас хочу сделать небольшое объявление. В 16:20, может быть 16:30, Свитла будет делать розыгрыш призов. Вот. А сейчас 10 минут перерыв и дальше Леран.
Это как всегда, единственный год, который я смотрел.
Когда ты полетел, стал лучше. Я полочку называю.
Что пришел туда на полет?
Просто подъезжаю, как сказал, что вчера я не стал в зале после конференции. И вообще такое беседа офигенная получалась, что получается еще люди, которые типа имеют мысли, если зале смотрят. На троих, на четверых, реально классно.
Эй. Эй.
Да, по максимуму.
Сейчас садились, на море, там Хватит. Вы решили остаться? Да?
Жесткий акцент.
Каретка? Сейчас второй регуляр.
Английский акцент. Ты когда снимаешь? Другие не снимают? Ну да.
Снова всем привет. Чё, как ваше настроение? Давайте похлопаем, покричим. После обеда немножечко устали, наверное, да? Надо посидеть, переварить, но нет, не получится. I would like to introduce you Liran Toll and his amazing experience in security vulnerabilities and how to find them before they actually found you. So let me introduce Liran Toll, please.
Thank you. Hi everyone, thank you for coming to this session and having some time to learn about open source security. I work at Snyk, I'm a developer located at Snyk, where we build developer-friendly tools for open source developers, like probably every one of us in the room, to help us write and ship more secure code in a way that is integrated in our development workflows. I will talk more about open source security in general vulnerabilities, so it's not a Snyk related talk. If you have any questions on that later, I'll be happy to take them. So a bit about me, I'm also a member of the Node Foundation, working on with the security working group. So if you're getting all those vulnerabilities from NPM audit, from Snyk, from anything else, that's probably some of those coming from the work that we're doing there. I am also involved in OWASP, which is a great initiative to help educate about open source security in terms of like web application security and stuff like that. I'm an active member of the Node Code project, so it's a vulnerable project that we can educate people about vulnerabilities and then fix them. I'm kind of a sucker for CLI tools, so I built those as well and had the pleasure of writing a book about node security a couple of years back. So any questions about any stuff like this, I'm happy if you want to tweet me at Liran_Tal and we can just talk about it, or just find me here afterwards and we can talk just as well. So I want to start with, let's talk about open source, how amazing it is, and what a better way to just start off like this, right? Yes? Awesome. Alright, so we're all using open source. It's pretty amazing. We're kind of contributing to it. Probably some of us here in this room, others are kind of using it, reusing code, our friends and everyone else's. But what I want to take you on a path here is talking about your libraries or dependencies and what you're using. So probably for many of the projects that you have, do this mental exercise and try right now to figure out which of these projects do you know all of those dependencies that you're using. So if you're talking here about JavaScript and Node, think about maybe Vue or maybe Express, and what dependencies does Express, for example, brings with it to the project, and do you know those dependencies, and do you know the maintainer that wrote those dependencies, and how often has anyone done on one of those dependencies a security audit? How often did someone do like the maintainer are they able to have security knowledge high enough for you to responsibly use this open source package. So as we ask ourselves about these questions, we get into a point where we don't really know much about those dependencies. And actually those libraries and dependencies that we use, they're written by humans, by amazing people, but at the end of the day, they're just, they're strangers. We don't really know each other. We don't have a lot of information about those dependencies, about the libraries, about the maintainers writing them. And just to give you kind of, I'm gonna pull you into this open source security and what exactly does it mean throughout this talk. And one of those is is we ran a state of open source security report a few months back, where we asked maintainers, developers as well, but also maintainers, how are they interacting with security with regards to their open source projects. So this, for example, was a question about maintainers asking them how confident are they in their security knowledge, right? They could rate it from 1 to 10. And as you can see here from this survey, just a few months ago, 70% of the maintainers, they do not have a high level of security knowledge. So again, this is kind of tying up into open source security and responsibility of using open source. Another question that we asked is, in that survey was, how often do those maintainers audit their code bases? So think about using a code base, any library that you may think of. How often do maintainers go through, for example, a security audit? Are they doing security application testing? Are they doing code reviews, secure code reviews to actually vet each PR? Are they doing that or not? As you can see, what I highlighted is basically that a quarter of those maintainers do not audit at all, like any type of security for their projects. So you can, just count your dependencies in your package.json manifest. 1, 2, 3, 4. That dependency did not go under any security audit. So this goes a bit, a bit far with how we are, responsible to open source security. And what I also want to mention here is, for example, we're all using NPM. Some of us maybe are maintainers, and I chose to include here a tweet from February from Adam Baldwin, a security person behind NPM, right, working at NPM, and he shared the numbers where only 7% of basically maintainers, right, because that's who publishes things on NPM, on the repository itself, have 2FA enabled. Now, two-factor authentication is really, really important. I will talk about it in 2 slides, but you can already understand why that is so important to protect your account from being compromised, from someone else being able to publish malicious packages. He has, so this is like a 7% is a very low number. Luckily for us, he has a very positive next slide for that, where he shared just last month that this number is already up to 20-something%, maybe 23, 36. So that's very positive, but still, as a general security mindset for maintainers, for developers, this is still a low number of people who have enabled 2FA for something that is as precious as an NPM package that may be used by a lot of us in this ecosystem. So as we talk about issues, with vulnerabilities, we'll see a little bit later, but let's talk about maybe some malicious packages, right? Because not everything on NPM is, that amazing. So there are some issues there that we need to figure out how to work around, and some threats that we need to figure out and understand what do they mean to us. So I listed 3 of them here, which are all a bit different from each other. Cross-env, I will start with that because that's kind of the thing that starts this timeline. Cross-env like this is a malicious package that actually bundles the original, the real cross-env package, which you write it with the dash between the cross and the end, which is a great package. By Ken Dot allows you to manage your environment variables, so it has a use. But if you accidentally installed cross-env like this, you would have actually installed a malicious package that when you install it, would go ahead and read all of your environment variables and send them to someone else. Now, no one uses any secret or password in environment variables, right? Great, I see the faces. So imagine someone, right, like, a developer, junior, senior, whatever, just adding, accidentally, installing this package into your source code. It's actually bundling the real cross-env. It means that you will not see any different experience, that you're getting the actual functionality. You merge it into production, it's going into master branch, it's deployed to production, then it's taking those environment variables, again, and everything that you have in them and sending them to someone else. Now, it's enough that this happens just once, and you've lost, a lot of precious information to someone else. This is a type of squatting attack. Moving on to ESLint scope. Everyone here, I guess, knows that. It's a very, ESLint in specific is a very prominent project in the ecosystem. ESLint scope is a package for it that, bundled within. And ESLint scope specifically had a malicious version of it published to the NPM repository, where when it was installed, it did something similar to cross-env. It took all of your .npm.rc, like all the tokens that you have inside, and if you're a maintainer, that token has a really, really, really important meaning, because that means that someone else is able to publish a package in your name if you didn't enable 2FA. So it would take all of those and send them to someone else. So again, another malicious package which you didn't have to accidentally install. It would just get bundled if you are using that project. And it happened, as you probably asked, how does something like ESLint scope get a malicious version? Because an account of one of the maintainers was compromised. So they were using a weak password, did not have 2FA, maybe their password was leaked through a data breach. Someone was able to hack through that and get this package published. The last one, FlagMobStream, is a malicious package that was used in EventStream, probably the most sophisticated and known attack that we've seen on the registry, on the ecosystem itself. That happened, through something like a social engineering attack. So all of these malicious packages, if you think about it for a second, they are different ways of attacking, end users, which is us developers at the end of the day, right? From having a typo squatting attack to a compromising account to a social engineering attack, all of which were able to be very successful in terms of impacting and actually compromising for different time frames, but actually compromising users. And this is developers. This is us at the end of the day. So let's take a use case where I'm talking about a serverless application written with a serverless framework. We don't have to read through it, but I can tell you that this is like 19 lines of code that I used to write a simple serverless function that fetches a file from a URL and uploads it to an S3 bucket. How many dependencies do I have? Are you able to see that? 2 of them, that's correct. I have AWS SDK, and then I have node fetch, which is a polyfill, and I am pulling in with those 2 dependencies 19 more, right? These are indirect dependencies that I'm pulling with me. But now just again, as a mental exercise, think about it. I am building 19 lines of code worth of, a production-ready serverless application that does something very, very simple. But when I'm pushing this to production, I'm actually pushing, 200,000 lines of code throughout all of these direct and indirect dependencies that, the application is now exposing. And this is an attack surface for someone else, where there may not be a problem in my code, but it may go through something else, and this is what I will show you later on in our live hacking session. So what would I think click for you, and this is what clicked for me as well when I saw it first, is as a developer, we are very, very focused on the code that we write, right, and not on the libraries that we use. So while a lot of time you may think that you're producing this, and sending this to production, the reality is that your code is actually just a very small part of it. And you're actually reusing a lot of, you're pushing code that is reusing a lot of other dependencies, pushing those to production. And this is okay to use open source. We are here because we want to make open source secure. But if you have this mindset, after this talk, this is the only thing that you're taking, having this mindset of, it's not just my code that could be vulnerable, it's everyone else's as well. And I don't know what's going on with, the rest of those libraries, and this is already like the first step of understanding how important this is. So some application security challenges that we're facing, right? Let's talk about it. So first of all, software delivery is sped up. Even if you are very security-minded, security-conscious, think about it. We are, as an organization of doing software development, we want to iterate very, very fast. We want to deliver stuff very fast to production, to our value to our users, etc. But then the question is, where does security fit into this model? Usually, like traditional application testing is, a pen test that is being done at, every quarter. This is like a really, really good use case. But usually it's not even that. But how does it go into like every commit that you're pushing in? So we need to think about it. The lack of security focus throughout the entire dev lifecycle. So think about the fact that not everyone is knowing how to handle security risk and application security. This is not something that we study in computer sciences. Security is something that you usually just pick up as a developer, and we don't have this expertise. And the expertise is actually siloed. So if you look at it from an enterprise organization, if some of you work in that, think about the amount of developers that you have, and then the ratio for the amount of operations supporting them, and then the amount of security people to handle that. The ratio that was checked to kind of give you a good example is for every 100 developers, there are 10 operations and 1 security person. And this is like, again, a very, very good situation if it happens at all, right? Usually it's a lot worse. So throughout all of this, DevSecOps is something that tries to answer this problem, just as if DevOps is trying to figure out similar examples. And again, to give you more ideas of how open source security and libraries that we use daily for JavaScript, web front-end development is so ubiquitous. Is, for example, as we tested something like 500,000 websites, we found that 77% of them have at least one vulnerable dependency. right? So that's at least, probably a website with a very outdated jQuery or Lodash or, something else that you're using in your code to build a website, then that's vulnerable. Another interesting fact about us as writing code is something we tested, this is from a couple of years ago, is as we look at vulnerabilities, like after they happen and after we discover them, if we can look at retrospectively back and say, from the point in time that this code was introduced, I wrote that, that vulnerable code, it was a bad, if, a bad sanitization, whatever, how long does it took until it was discovered, until someone found it? Do this mental exercise for a second and think about how long can it happen? What is the worst case, or in this case, what is the median, what is the average time? The answer to that is pretty overwhelming, right? It's 2.5 years as an average time for when a vulnerable code, like an insecure code, was added to a project until it was discovered. That's the time that a vulnerability lived in the code base throughout the project's lifecycle. All right, so with that, maybe let's do some live hacking and go through some real-world vulnerabilities. So I know for some of the people in the back, let's try to make sure that you're saying things, and if not, just raise your hand and I'll take a look and to increase the font, etc. So what I'm going to show you is there's a to-do app over here. I think you're not seeing the, oh, there we go. So there's an input here, but the projector is having a hard time showing it if I'm not talking over it. But basically this is this very simple JavaScript application to do up, just for the exercise experiment. And what we're going to see here is some use of open source libraries and how they manifest as vulnerabilities. So I can go ahead and write hello Odessa. And I can go ahead and since this is using Markdown, I can go and use the Mark library and just write Markdown. So I can do like this. And I have a link. And as you go through this experience, and maybe you want to go and try to add XSS into it, you might think, let's go through the classic case of adding just the script tag and trying to exploit it. The thing is that this library has the ability to sanitize this input that I'm giving it. The bad thing about it is that by default, this version of it is actually, you need to opt into security, so it's disabled by default. So for us, I actually enabled it to kind of make it more interesting, and we're still unable to hack it. So what I can do more is think about how JavaScript links can manifest. So I can go here and add JavaScript like that. I can try to hack this. I'll make it a bit larger. And we're seeing that Mark was able to sanitize through it and figure it out. So far so good. Seems like things are working well. Except, what if we try to kind of go and tweak the sanitization in how things are done? So maybe I could go and replace the column. I can see how marked, it's open source. I can go to the repository, look at the code, read it, and figure out how it's actually trying to sanitize and escape it. So maybe it's looking for a JavaScript column, and maybe I want to replace that. So I would do something like this, for example. And I could do the same here. So basically now I'm just representing a column as the as the HTML entity for it. So which is this, right? And this is a way to kind of go ahead and trick any kind of sanitization. But things look like as if Mark was able to escape that as well. If we go to the code base, we'd actually see that it's actually trying, there's a regex that matches these kinds of strings, and it's smart enough to, whoever wrote it was a smart developer in terms of security awareness, to go ahead and try to figure out all of your escape hatches. The only problem here is that there's a connection between how the browser interprets stuff and what you send to it, right? All the stuff that you send to it. So in our case, the way to trick that is what would happen if I would put a valid JavaScript statement like this, or for example, you could put a document inside as well. And this goes just fine throughout Mark, because Mark has doesn't cover this in the regex. But if I do this, what happens is the browser, it will go ahead and say, well, I think that this is a mistake and you probably meant to add a semicolon here, so I will close it for you. as browsers usually do. And let this in. And when this happens, then now this becomes a valid JavaScript statement. So if I have something like that, this is now an XSS that we were able to inject through Marked, which is vulnerable to these kinds of attack. Right? So at the end of the day, you could add better sanitization in how Marked works, and this was the fix that was later on brought into the ecosystem. So Marked, just to give you a representation of how popular this is, right? Marked is a project with 2 million downloads a week. Okay, they're already alternative because this is pretty old project, but it still gets downloaded quite a lot. And use it on the server side, you can use it on the front end to do these things. So it's something that is pretty common. And when a vulnerability arises in a dependency that we are using, this is something that is important for us to figure out how to fix it and remediate it very quickly. So I want to show you another example of vulnerability that can happen here. As I scan the project through Sneak before, and I'll show it later. But basically, there's a couple of other vulnerabilities that we have here. Let's choose just one to proceed with the demo. So as I add a new text, let's look at how that shows. So when I add something, so you can see it. So it's going to send this request to this create endpoint, a post request, to just add this item. So let's go ahead and try to do something with that as well. So for example, what we can do is say, buy borscht in 5 minutes because I'm in Ukraine. And what will happen is there is logic in this to do up, as would probably be would make sense. To translate those 5 minutes as a text, kind of like a DSL thing, into 5M to represent it in a different way. What is doing that is a library in the code that is called humanize.ms, which is gets fair bit of download as well. Interestingly enough, humanize.ms is kind of just a small wrapper around MS, which is completely more popular. So if we were able to go ahead and check MS, that would be tens of millions of downloads. As that goes, I will open the code and we can see what's going on there. So I have my routes here, and there we go. I have this parse function which uses HLS, which is the library that I showed you before. And you can see it's trying to parse what I'm giving it, so by milk, by borscht, whatever, by something. It's a very simple parsing in terms of what it's trying to do. Regexing it through it, and then passing it to HMS to represent those 5 minutes into 5M. That is just displays maybe in a better way. But this is all that it does, right? Let's get that maximized. There we go. This is all that it does. MS is fairly popular, and the thing is that MS gets that 5 minutes, and it tries to do regex to figure out what is the input and give you this representation of numbers of microseconds into it. How it does that? Of course, using regexes. So let's talk about regexes for a second. So regular expressions are basically state machines that are trying to evaluate an input and a pattern and get into the end state of it. Specifically in V8 JavaScript, the engine is a non-deterministic finite automata, which means that it's going to go and try one by one each state until it reaches the end of it, the end of the input or the end state itself. And if you want to think about what does that mean, is think about a maze where you have a mouse, and the cheese at the end of it, and the mouse goes into all possible ways, retracts back, go again, retracts back, go again, until it reaches the same state. The thing is that in extreme situations, you could trigger the regex engine, which is compute resources bound, to go ahead and evaluate into an exponential time, and require a lot of time for something that evaluates the regex. So what is kind of often is missed around developers is the fact that regexes are CPU bound. And if you have a vulnerable regex, that means that in Node.js or in JavaScript specifically, that's going to block the event loop, and then no other thing can be processed during that time. So this is what I'm gonna try and get into with this demo of being able to try and do a denial of service to a regular expression, which what is happening with MS. So as we've seen this network call, I'm gonna go and send something here. Is this something that you can see? Okay. And I'm going to open monitoring a bit lower so you can see the CPU being used. So I'm going to send content is, let's make it short. So I'm using the HTTP tool. It's just a simple Python thing, and I'm going to be able to send that. And when I'm done, you can see the request going in. Right, and then by milk in 5 minutes, that's okay, that's what we expected. But then I can go ahead and what if I was able to send a bigger number? What if it's not 5 minutes? What if it's increasingly a large amount of numbers to go ahead and parse? So what if I could use something like sequence like this. I can format the number 5, use a separator nothing and repeat that 1 time, that's great. Let's repeat that 10 times. Sorry, let's repeat that 10 times. And this is what I will try and feed into my my content that I will try and inject. So instead of this, I will go ahead and replace it with that. I like that you're using ICQ. So big kudos for that. You can connect afterwards. I have a 6 digits number, so pretty awesome. Alright, so I'm gonna go and send in 60K characters of 5 and see what happens. Amazingly enough, nothing. Right? It simply parsed it as infinity, which kind of makes sense. Like that's kind of what we would probably expect. So I'm now gonna fire up the hdub tool. I think that me maybe this here. We can switch to this in a second. So with hdub, I'm gonna check what is my node process doing. And here, we can go and do something different. So as I told you, with regular expressions, we can go and trick the regex evaluator, the engine, into getting, if it's a vulnerable regex pattern, we can trick it into getting into an exponential time until it evaluates. So for me, it's enough to say, in this pattern, for example, I will not use the word minutes. I will just change that with mineta, because the regex pattern that the MS library is using behind the scene is trying to evaluate, something, some number minutes, or something, some number hours, etc. So it's not going to find minutes, and it's going to go and what it does, it actually does a backtracking. So it's going to go and not find minutes, and then it's going to backtrack and 5 minutes, and then backtrack and 5 minutes without the e, etc. until it's able to do that. But it's going to take it an exponential amount of time to do it. So as I do that, first of all, you can see that the UI is not responsive anymore. If I go to hdub, you can see that node is now consuming 100% of my CPU. No other requests are getting processed, and just a few seconds later, you can see everything getting back into shape, right? Everyone got that? Cool. All right. So this is an example of a regular expression denial of service, where it's not I am not fond of writing regexes myself. But even if you don't try that yourself and you're using some library, that's also a bit vulnerable, and you can have these situations. So let's go through another vulnerability. So I have this about page, and it's called about new. So I'm a great front-end developer. It's a mobile-first device. Let me prove it to you. I'm a mobile-first app. If I add desktop, it's a bit smaller. If I change it to mobile, it's a bit bigger. Yay, mobile-first. So what would happen if you were able to go ahead and do something around this input? So for example, let's say, let me show you first what's happening here. So with the code itself, it's using OdessaJS as a templating engine. And what it's trying to do is, have some logic. So if I'm giving it the device's desktop or mobile, it's going to draw different sizes of the font that you've just seen. The thing is, OdessaJS is a templating engine that the way that it works is it's going to go and evaluate whatever input that I give it, because that's kind of how template engines work, right? So if I was able to inject somehow something into the condition here, I would be able to evaluate this on the server side. But it's not so easy to inject stuff because Dust is a security-minded library, and it means that it has those escape HTML parts. So if I was able to try, if I wanted to try and escape it, with some strings, it would go ahead and convert them and encode them to something that is is not able to escape the context of what I'm trying to inject. So again, if we go to what's happening here, like what would I try to do? I would go and try to somehow escape, right, this logic to be able to add my own into this condition variable. So the first thing that comes to mind is maybe we can add a quote, like kind of escape what's happening here with the quotes. But we're seeing that this is actually handled, and this is what we saw before. And if I would be trying to do something kind of near that area, then let's think about what's going on. This escape thing, if you look at it for a second, if that's like big enough, this escaping function, it has a flaw. The flaw that it has is that it is only applying it if my type is a string. So what if I was able to send something that's not a string, but something else that would just pass through this, but still be a string at the end of the day because I need to pass it into evil. So this is where, for example, another kind of vulnerability / attack is made possible. Like what happens if I would represent this as an array with the bracket notation, and I would go ahead and try to send an array, device array equals mobile. So this works because if you do a toString to an array, we're going to get the first element. So this kind of works in terms of functionality. So it looks like nothing is broken. But if now it's an array, and if I'm trying to kind of inject something like a single quote again, I'm going to get this error from evil telling me that something is happening there. And this is where things get interesting. So using an attack like an HTTP parameter pollution, which means that I'm sending stuff sending like query string variables that the server may not know how to handle, I'm able to kind of manipulate the internal logic of the thing that's going on inside. So to show how this goes a bit further, where is our code base? There we go. So we can do something like this. And so far so good. I sent a request, I got a reply back. I'm going to go and escape it. So I'm going to go and escape that as well, as an illegal character. And I'm seeing that things are still working okay. And I'm adding a single quote, and things are now broken. Like you can see on the left side, the syntax error from my request. Now, how would you go and exploit that, right? So think about node itself and how it works. Let's do an eval exercise. What's really happening there is something like this. Right, let's see, yeah. So what's really happening is something like that. I'll get a bit larger. I see that some people are having a hard time reading it. So it's evaluated true, of course. Obviously, that's what's happening. But then I can go ahead and try to make that's a value, right? So I can put an expression there and see what's going on. So I can do something like this. Console log 1, whatever that is, subtracting it from something else, basically even nothing, I don't really care. And what happened is this is again an expression. So it's going to go and evaluate it. So it's actually running this function expression, console log, and I'm saying that as 1. So it's as simple as simply running that, right? And let's see what's going to happen. Oh, lost that one. Let's see, grab this again. Right, so at this point what happened is I actually executed console log 1 on the server side because that was what evaluated, because we escaped throughout all of this learning process about this vulnerability and being able to execute that. So if you think about it, like at the end of the day, what the attacker will do, of course, is not console log. I can go ahead and change that with a simple exploit to do require child process, or run some other stuff that I want to do. Invoke a reverse shell, do whatever I want there, etc. So far I think about vulnerabilities in open source libraries. And as we kind of walk through this exercise of understanding how vulnerabilities are not just in our code, or also in open source vulnerabilities, we come to realize that attackers would no wonder try to gain access into open source and either through malicious packages or find and exploit those vulnerabilities because of the simple package economy, right? How many packages are on NPM and how many people are using them. So if an attacker is able to exploit something in MS, in OdessaJS, in SD, in so many libraries that Lodash recently, etc., what would happen is one exploit in that would actually affect many victims. So it's a very economically good trade-off to try and do. To explain a bit more about why is it so challenging to actually address open source vulnerabilities in those libraries, as with something like Snyk or anything else, is understanding that package dependency is something that is kind of complicated. Because if you think about it, it's not just, like we said, not just a direct dependency, it's actually that nested dependency and then that nested dependency, etc. And what happens if you have a three-level steep nested dependency, like we had in this app, the Goof app, HMS, and then MS. And what happens if MS is vulnerable, which is the version that HMS is bringing in, and there's a fix for MS, but actually there's no upgraded version, there's no released version of HMS to get that fix because the machinery has gone, is not active anymore, etc. You're going to get stuck with that vulnerability, and we need to figure out how to manage that. This is part of like Snyk patches that kind of helps you handle that, but it's a very not straightforward way of challenges that are happening with package ecosystems. So this kind of shows how we find vulnerabilities. So as we kind of gather data through Snyk users, like this is basically people that we just scan their package manifest and requirements, Python, JSON, whatever that is, and we put it on a bar. And we have plotted where do we find vulnerabilities. So where do we find direct vulnerabilities, and how often do we find indirect vulnerabilities? And as we're JavaScript conference here, we're talking about NPM, which is the top right, the most right bar. You can see that in most of the time, 78% to be exact, we find vulnerabilities in indirect packages. That means even if you are a very responsible developer and you are following all the change logs and security announcements of React or Angular or Vue or whatever, most of the time, we're not going to find vulnerabilities in those packages. Most of the times, as a fact, we're going to find it in those indirect dependencies. And this is why having, some tools, some way to help you manage those dependencies and the security around them is so important. So after all of this, right? What if security was easier? What if it was actionable? What if it was a bit more developer friendly? So like you wouldn't get a report at the end of the day of this and that is vulnerable, but something that would be tied into your workflows. So for example, what if you were able to open pull requests to automatically relock your files, your package JSON, your yarn log or package log, whatever that is, upgrade to the most minimal version possible, right? So you want to upgrade to a minimal version just because if we change that, if we make an upgrade from 1 to 2 to have a security fix, that also means that you're going to get maybe a major breaking change in the API of that library. So it's important to actually make smart upgrades possible. And that's what actually is happening there with MS, right? It's a patch version which the security, the maintainer was able to release as a security. And then if you have this in, the only thing that you have to do is, of course, make sure that all of your tests are passing, nothing has broken from updating a dependency that you have, and merge it in, right? And this is kind of what we're trying to get into with DevSecOps, is having, having all of your code coverage, having all of your Travis or Jenkins or SQL CI testing there, having something like Snyk, it can be anything else, can be Snyk as well, to have it and test your dependencies and check that someone is not adding a vulnerable dependency and block the build and not allow you to go forward until you address it. So I want to thank you for joining in today. I want to say, use open source, but stay secure. And if you want to ask any questions or talk to me, I'm going to be right here. So thank you very much.
Yeah, so basically don't trust anybody in open source. We have a couple of minutes. We can ask a few questions. If you would like.
Right, so, no?
Guys need to think about it.
Alright, I'm gonna be here, so catch me and be really thrilled to talk to you.
They need to start to check their open source packages.
For sure. Thank you. Thank you.
У нас 10 минут перерыв. Сейчас как раз Светла сделает свой розыгрыш. Я желаю удачи всем.
the first day of Tomorrowland. Time is come to introduce you to a new chapter.
Всем привет еще раз. Надо музыку выключить. Так получше будет. Кто знает, зачем нужно ходить на конференции? Ну, не только на доклады ходить. Вот зачем вы ходите на конференции? Кто сколько набрал уже наклеечек, стикерочков? 1,5. Хорошо. Сразу видно, парень приехал сюда затариться, потом будет себя продавать в компании. Хорошо. Вы видели наших спонсоров, там, стоечки, игры, головоломки, у Grammarly вообще какой-то тест они сразу на работу берут. И вроде как, я не знаю, не прошел. Так, значит, Одна из причин, почему я тут, это мне нужно сейчас немножечко вам понудеть, рассказать про наших спонсоров, которые вам раздают стикерочки. Стикерочками они решили не ограничиваться, и будут призы покруче. Значит, что будет? Сегодня в 18:30, ну вот где-то через час небольшой. Ух, тут сейчас много будет букв. Значит, на этой же сцене, в зале А, я надеюсь, я не перепутал залы, значит, в зале А, это здесь, будет розыгрыш брендированных призов от OdessaJS, а также наши спонсоры сегодня разыграют EvoPlay, JBL-колонка. Ну, такая, взяли с собой и пошли из Bluetooth. Зон 3000, классные брендированные подарки. Звучит очень интригующе. Рюкзачки со стикерочками. Светло, вообще яркий чемодан. Я очень хотел бы этот чемодан получить сам, но у меня не было времени оставить анкетку. Просто чемодан фиолетовый, машина у меня тоже фиолетовая. Это судьба, но пока не сложилось. Чемодан и много ярких других подарков, не только фиолетовые. Светло, да. Банк Пифтенный, вот, кстати. Они разыгрывают 4000 гривен, но не кредит. То есть они просто делают розыгрыш 4000 гривен. Специальная карточка от банка Пивденного. Приходите, оставляйте им анкеточку, участвуйте в розыгрыше. Реальный банк реально 4000 гривен дает. Вообще. А Татарт вообще будет 4 приза. Apple Watch. Ну прям вроде настоящий. Камера 360. Портативная колонка и фитнес-трекер. То есть ищите дата-арт, у кого еще нет Apple Watch или кто хочет, вот, можете попробовать поменять там 15 или сколько там было у тебя стикерочков, может сторгуетесь. Вот. В общем, на 18:30 розыгрыш крутых ценных призов. Участвуйте, обменивайтесь. And currently I would like to introduce Alfreda, and who is actually, from my experience, the best experienced specialist in performance and how to work with it and how to live with it. So, Alfredo Lopez.
Hi everyone, I'm Alfredo. I'm a director of engineering at Hearst, which is a media company with more than 360 businesses. And its major interests include magazines, TV networks, newspapers, and more. And some of the properties that you might be familiar with are Cosmopolitan, Esquire, and Elle. But there are a lot more. In total, we have 100+ websites, and they're all being powered by one application. It's great because it gives us a lot of control, but we have the additional responsibility that when we break something, it affects 100+ websites. And that's really bad, especially when it deals with performance. So for us, performance really matters. And today I would like to share a few technical tips that we've done in the past, are doing, and are planning to do to speed up your websites. But most importantly, how you can embed performance into your culture, because you can do all of the stuff that I'm going to show you today, make your website really fast, then a few months pass and everything goes back to where it was before. So to me, it's the most important part of working on performance is how can you make it last? How can you make it stay fast after that you work on it? So the reason why performance matters, and this varies depending on what you're working on, but mainly it's because people don't have patience. And if something is slow, they just leave. And for us, we found that the sweet spot is around 2 to 2.5 seconds. That's when most people feel like they're waiting, and that's just how humans perceive time. After a second, we switch to what is called passive time. And after humans enter passive time, we overestimate time by 36%. So anything that you can do, be that animations or something, to keep someone engaged in active time, the more that they're gonna feel like they're waiting. So without showing anything, we can see that here before our median page time was around 9 seconds. I don't know if you can see it, but it's 9 seconds. And we can see that at 2 and 2.5, there's a drastic up of people just leaving because nothing of value is being shown here. So that's our goal. We needed to have something valuable shown around 2 and 2.5 seconds on a mobile, on a 3G connection. So where do we start? How do we start getting stuff done? And the main approach that is mostly advocated by performance advocates is to get the executive buy-in. And what this means is, how do we convince our bosses, the executives that are making the decisions of where do we spend time, to put away some time for performance. And what you can do is, first you have to measure. You can't optimize anything if you don't have anything to compare it to. Using OdessaJS, which is open source, you can run your site and see how it performs on different devices with different connections, be that a mobile on 3G or 4G or desktop with Wi-Fi or slow Wi-Fi. And a good tip that you can have is that you would script, with a small script, you can see how your website performs without third parties and with third parties. So you can compare how much you can control and make faster and what's something else that you are bringing in because they're helping you, giving you some revenue or something else, but you can compare that performance effort. Also, you can use Lighthouse right from the Chrome DevTools and also as a node module to just give you some performance scores of how the website is loading. Both of these tools are known as synthetic testing because they simulate users and devices. And this is helpful because as you are doing optimizations, you really want to know accurately how much they're improving, or if you have a regression, how much time you're actually losing. So the scenario has to be dependent. On the other side, there's RUM, which stands for Real User Monitoring, and this gives you the same metrics but on a real user device. With a smaller library like Perfume.js, you can get all of these metrics, and including first input delay, and you can save all of that to Google Analytics and also support any custom analytics that you might server that you might have. So you saw some of the metrics that you can have during the page lifecycle. There's time to first byte, there's first contentful paint, there's time to interactive, and personally, we found that FID, which stands for first input delay, was the most important metric, and I'll tell you why. Because it measures the time from when a user first interacts with your site, example, when they click on a link or tap on a button, to the time when the browser was actually to respond to that. And the reason why we found that's important, because there's a behavior known as rage clicking. That means that when users tap on something and it doesn't respond and they just keep tapping and tapping and tapping, that's known as rage clicking. And the difference between users leaving because the site was too slow versus users leaving because the site didn't respond, we found that the first case, users leaving because nothing was shown, they're most likely to come back, but users that were frustrated because the site didn't respond do not come back because they got angry. So this metric, out of all of them, we found the most important to track. And now that you know those metrics, now you know where you stand, you can start comparing yourself to competitors. Using the Google Chrome UX dashboard, you can get the same metrics on any other website. You can get first contentful paint, and I believe a couple of months ago, first input delay was now recently added, so you can get that as well. And you can get their connection distribution, 4G versus 3G, and also device distribution, desktop versus mobile. It's logical to try to compare yourself on the same device with the same speed, but I recommend you to see where the 95 percentile is. So your competitor, that most of their users might be going to a different device or a different speed than yours. So it's not accurate for you to be measuring yourself against them on the same speed if the majority of the users are going on a different device for different speeds. There's also another side, think with Google, where you can benchmark the mobile speed index. This is the aggregate of all of the metrics. And you can really quickly see where you tally against everyone else. This is really helpful to show non-technical people or executive leaders. And most importantly, they also have a performance calculator, which shows you that when you input some different variables, it shows you how much money you're potentially losing by not speeding up your site. When I was showing this to my bosses, I still had some slides left on my deck, but they stopped me when we saw this and they just told me go and do it. So now we had approval. We have some time to go and work on this. So we have to find where is the bottleneck. There are many things that can slow a site down, but we try to find what is the one thing that we can fix and will give us the most impact. And we found that it was JavaScript. Like Liran mentioned, regex CPU blocking. Actually, JavaScript is CPU blocking. Anything that JavaScript runs, by default, it runs on the main thread. Browsers, anything that goes through the browser runs through the main thread. And anything that blocks the main thread blocks absolutely everything. That's users clicking, users scrolling, anything. So JavaScript, if you are not careful, can block absolutely everything. And also, if we see an HTTP archive, we can see that we've only been adding more JavaScript as we go through time. The Medium webpage has a 350 kilobytes of JavaScript being loaded on page load, which amounts to 15 seconds of time to interact it on mobile 3G. Now imagine loading something and not be able to interact with it for 15 seconds. That's the most common website in the world. And also, this is the median, which is the middle number of the total. The average, which is reflected, I don't think that you can see it here, but there's this shadow. This is the average, which is actually 500 kilobytes. So why is JavaScript different, right? Loading at 200 kilobytes of JavaScript will not, it's not the same effect as loading a 200 kilobyte image, because all bytes are not equal. Like I said, a 200 kilobyte JavaScript takes much, much longer than a 200 kilobyte JPEG. And why is this? Because JavaScript has many different steps. First, it has to download from the network, from a server. Then it has to parse and compile so the browser can understand what it does. And then it has to execute and run. And each one of these steps has a cost. So download, that's why we minified and we put it on a CDN. But until last year, parse and compile used to be the top, more expensive part of the process. 10 to 13% of time was spent on page load. And then the JavaScript would have to execute. But this year, the Chrome team has made some parsing updates. And they're able to do what is called script streaming. And this is that as soon as they see 30 kilobytes, they're able to start parsing and compiling some of that JavaScript as it's being downloaded. And on Chrome 71, they moved to a task-based approach. This means that using worker threads, they're able to run this concurrently. So as multiple files are being loaded, they're able to parse and compile at the same time concurrently. I do want to go back to this because you see that number of 30 kilobytes. This is an interesting number because as code splitting has been given as the most performant technique that you can do, developers usually don't know how much you should code split. And you end up with really tiny bundles that are loading at the same time. And while HTTP2 loads all of these bundles concurrently, it does have a max connection that I've seen 6 to 8 connections at the same time, similar to HTTP2.1, where anything after that is being loaded concurrently will be deferred. And now that we have this recommendation of 30 kilobytes, the recommended size to be able to take advantage of this approach while also not have other browsers be slow is to have your bundles be near 30 and 50 kilobytes. And this approach led to up to a 3% PTI improvement simply because the main thread has been allowed to be free to be able to do something else. So knowing all of this is how we were doing before. We had a 150 kilobyte bundle on our feed pages that added up to 360 kilobytes uncompressed. This took, and to parse and compile, up to 2 seconds on mobile and 3G. And this line that you can see here, this is the main thread activity. This is really bad because this means that nothing else at this point can happen. It's just blocking the main thread. And this added up to our load time of almost 13.5 seconds. So now we knew everything. We knew why we were slow, and we knew where we wanted to go, and we knew how we were, what were our metrics. So now it's time to make it faster. The first question that we ask ourselves is, does the user need this right now? Whatever it is that you're loading, this piece of code, does it need it right now in this second when you're loading the site? And a good starting point is to always just defer things. So there's a document lifecycle, there's document load and window load, and that's really easy, but I feel like the next step is to infer by user action, and what I mean by this is being able to track what the user is doing and kind of predict what they're going to need eventually. So we have an example on our feed pages, this infinite load feature, and what it means is that as the user is approaching the bottom of the feed, we load more items and we put it underneath. So the usual approach is that you have a scroll handler and you track the user's scroll position, and when they're nearing the bottom of the feed, that's when you load something. But using intersection observers, you're able to get the middle element of the feed and observe it. Now you do need an is intersecting check because this callback, the intersection observer callback, fires right away when you observe something. Now remember that because it's going to be valuable. Now, once it actually is intersected, we disconnect it, and this is when we load the actual code of infinite load. This is the code that is doing that AJAX request and is putting all the modules underneath. This means that on page load, that code isn't there. And if someone doesn't scroll far enough down, they never see this code. And then we set up the feed element to that module, which does a similar technique, only that it observes the bottom element with a threshold up in order to do that AJAX request. We can also do progressive enhancements. For example, we have a search modal that has a type ahead feature. What it means is that as the user starts typing, we offer them some suggestions. But when we think about it, what is the most critical thing that the user needs to do is to be able to open that model, start typing, and hit enter. At that moment, the type ahead becomes an enhancement. It's something nice to have, but it shouldn't block the user action. So we divided that function, that type ahead function, into another bundle, and we realized that in order to open the modal, we don't really need to JavaScript. We can do it just on CSS or HTML. And this allows us to be able to disable JavaScript altogether, which mimics the environment where someone is in a really slow connection. So here we're disabling JavaScript, opening the modal, and the user is still able to type and hit enter. And to do that, we use the CSS target property, which has been on the language for a while. We use an A tag with an href, which will change the URL. And then we have our modal with that ID. And then on CSS, we have the column target. And we just use a Z index to be able to move that modal from the background to the foreground in order to show it. This works on every single browser, even IE10. But there's a better way, which is a little bit modern, and you can polyfill it, using details with summary. Details is an HTML tag, and this is all the HTML that you will need. And this is some of the CSS that you will need. And I have this glitch, which you can go and remix it and see all the code. And on the left, I'm using the CSS target, so you can see the URL changing. But on the right, I have the modal. All of this is happening without JavaScript. It's only HTML and CSS. And the use of web workers, not to be confused with service workers, because service workers are the network side. It's what is really critical to do a PWA, for example. It's what allows you to cache a file and serve it offline. But without web workers, you're still going to run that JavaScript on the main thread. So a common weakness seen on PWS is that they need to be updated. And an update is usually additional file size. A new feature was added. And so they show a button of update. And when you update, you load that new JavaScript, now that is bigger, and it runs on the main thread. And at that time, you could actually crash the browser. And that's the worst experience that you can give someone, that you are updating the PWA and you crash the browser because you're doing that. So web workers allows you to not do that because it offloads work from the main thread. Using a library like Comlink, you can easily move something off of the main thread. In this example, the object app, it's in a worker thread. So when we fire do something, all of this that happens in do something is off of the main thread. So what are the pros? I mentioned obviously offload work from the main thread, but the most important plus that I feel web workers have is that you can run as many web workers as you want and they run in parallel and they do not block the UI. Meaning that you can have many web workers doing separate things and they don't block the UI. Even though web workers are now very, very well supported, people don't use them very much because the people think like you should only use web workers when you're doing really intensive things, like if you're creating an image or you're rotating it or you're cropping it. But I would advocate that you should use web workers for everything. Because whatever blocks the main thread, even if it isn't you, if it's third party, you're done. The user is going to be blocked from doing whatever they need. But they do have one downside, which is they cannot access a document yet. And I'll get that to in a second. Now, we use Comlink, which is a 1.2 kilobyte. And there are other workerize, or I forgot the other one. There's a couple more libraries, but whatever you want to use, please just switch to web workers. If there's anything that you take away from my presentation, use web workers today. But there's a misconception of when I talk to people about why do you use web workers, they usually tell me this. But post message is slow, which is the mechanism that web workers use to communicate with the main thread. And I say, well, no, it depends. Earlier this week, I was very fortunate that Surma from Google did a really intensive research into the performance of post message. So I don't have to. And he found that even on the slowest device, you can post message objects up to 100 kilobytes, and you stay within your 100 milliseconds response budget. 100 milliseconds is the time where the human eye still perceives something as being smooth. Anything after that, we start seeing it as like something is slowing down. So that should be your response budget. And if you have JS-driven animations, you can have up to 10 kilobytes of payload are risk-free in order to not make that animation feel slow. Now, what I would add to this is that if you are doing JS-driven animations, please consider CSS first and add JS on top of that. And the reason why is because with CSS, you can access the hardware, so you can have really reliable animations. And also, in multiple browsers, they have a compositor thread that caches CSS animations. And you can test this by having an infinite load on your file and a CSS animation. If you have an infinite load, everything will be blocked. You can't scroll, you can't do anything, but the CSS animation will remain playing. That's because it gets offloaded to a compositor thread, and that's where it's just cached forever. And I did mention that currently, the one downside of web workers is that you can't use the DOM. But there's a new library called Worker DOM that is in alpha right now, and it lets you do exactly that. It provides two files, one index, that add this main thread element that lets you upgrade an element that has a source, which would be your file. And in that file, you can create elements, add them to the DOM, and add event listeners. So in this case, I added an input tag that I detect that when I type change, I run this function that all it does, it checks that if my color is green, I switch it to red, otherwise I switch it back to green. And this is how it looks. Now, this is obviously a really trivial example, but mind you, all of this is happening off the main thread, meaning this will never block the user. After after doing all of these optimizations across many different bundles, this is how we ended up after. Our bundle went down to 9.4 kilobytes, which is 27 kilobytes uncompressed. We didn't take advantage of the 30 kilobytes there, but we did this before Chrome did that optimization. And now it's loading at 220 milliseconds. And you see these little blocks spaced out. This is beautiful. This is what you should strive for, because see, in this space, anything else can happen in that space. The user can interact, other scripts can load, anything can happen. The main thread is free to do whatever it needs to do. And it bundled up to that sweet time that we were looking for, 2.5 seconds. This is when we're able to show the user something that is valuable, so they can continue and decide that the content is valuable for them to remain on the site. To put that in context, that's 4 seconds faster of first content opening. This is how we were loading before. We don't see something until about 6.5 seconds. And then we're finally loaded at 13.8. And this is how we were before, after. At 3.3, we're visually complete. And this made it clear that we needed to work on other optimizations. So for example, we see that at the beginning, we only see this a pink rectangle and not the fonts and everything. So we were able to do more smaller optimizations, like adding a background with a CSS loader to improve that perceived performance. But there was a difference here. This is all page load performance, and there's runtime performance, meaning after your page loads and the user starts interacting with it, that's runtime performance. Our runtime performance was still pretty bad, and so to our bosses, everything is just one thing. Everything is just, why is the site still slow? Sure, it shows up fast, but I still can't interact with it, or it doesn't react as fast as I want. And to talk about this, we need to talk about first party and third party. Like I mentioned, first party is everything that we can control, and third party is everything that we can't. This is a web page test waterfall of that 2.5 seconds. And I broke it down in colors. The first part are 11 requests. First party, these are the resources that we control. Our fonts, our CSS, and our JavaScript. Then our tag manager, which is what controls all of our third party, loads on the 7 requests. And it loads our third party, which loads 125 requests. Now, besides the amount of that, or whatever those scripts are doing, the problem that we have is that we can't tell where all of these third-party scripts are coming from, because it all happens on the fly. It all happens there. If you're not familiar with header bidding, everything gets sold right away as the page is loading, because that's when it's tracking what the user is, where they're coming from, what language they speak, in order to deliver the appropriate ad to you. So when our leaders were asking us, why is the site still slow? The answer was pretty clear, that it was that. So this is something that we're currently working on in order to tackle this, because it's not as easy as saying, well, just remove it or defer it, because third party is what is giving us money. And that was the main thing that we convinced our bosses, saying that by making our sites faster, we're going to make more money. So we couldn't just contradict ourselves and remove third party that would directly affect our revenue. So this is an approach that we're currently experimenting with. We use a Lambda function to load our sites with a first parameter called third parties. And it performs as regular, our tag manager loads all of our scripts. But we track, so we give our Lambda function using Puppeteer the list of what we consider third party. Anything else outside of that is third party. So what it does, it collects all of those resources and uploads them to S3. And at the same time, it stores all of those references on Redis, but you can use any in-memory DB. And then, when the real site loads, all the users are still loading all of these files, but they're coming from our servers. because that means that we don't have to open all of these connections to 125 different domains. We can just load them from one domain. And this opens the door to any number of optimizations that we can do after that we store them, because, for example, we can run a regex of saying if there's any document that query selector code in that file, and if it's not, we're able to put it on a web worker, for example. But for now, simply doing that optimization, uploading everything from one domain, we're seeing up to 20% improvement. And now, either on content invalidation when this page changes, or at a scheduled time, be that every hour, we trigger the same function, so we do all the process again, so we can update our ads or update our third party. Now, this is important, like I said, to speed your site up. But I'm going to talk about how can we make the state fast, and to that we have to talk about how can we include it in the development process. Performance is huge. There's so many different things that you can work, and we decided to divide it on 3 main categories. The server, which is API request and CDN, application, which is HTML, CSS, and JavaScript, and development, which includes our build CI speeds. And each one of these have potential bottlenecks. This is a comprehensive list put together by Paul Irish that lists all the things in JavaScript that are render blocking, and it's a lot. And so when you're learning all of this stuff and you're bringing it into your colleagues and you're bringing it in during reviews, it can be pretty overwhelming for everyone, because it means, well, what do I do if I can't use any of that? And I found that the better question to ask is, what do you intend to do? What are you trying to do? Because we shouldn't demonize all of these properties, because they're all valuable. And the more that we ask this question, we're able to abstract frequent optimizations and not just say, no, don't use that. And I wanted to talk about get bounding client right. Who here is familiar with this method? Great. It's an amazing method. It has been in the standards since IE6. And what it does, it gives you the top, left, bottom, and right positions of an element, regardless if it has position relative or static or fixed, and it's the most precise. But there's a problem. It wasn't the list, so it's bad. And there's a way to get around it. Using request animation frame, you can defer when you actually request an animation, but there's a problem. If someone else on a different file is also having a request animation frame that changes the size of the same element by adding a CSS class, then the first part is as bad as not doing it, because it will still go back to the render steps in the vendor. So do you remember when I told you what happens when you observe an element and the intersection observer callback fires right away? We can take advantage of that and see that the entry, when you observe something, has this information, has the bounding client rec information right there. So knowing this, we're able to write our own asynchronous get bounding client rec that on the fly creates an intersection observer, gets the entry, the first entry, because simply we're observing one thing at a time, and it sends you this bounding client rec. So in your code, you wouldn't write a header or element get bounding client rec. You would await on that function that you created where you pass the element. And this is what I talk about performance culture. A developer doesn't have to know why this is better. They just need to know that this is what they need to write instead of this. And the more that we start developing those patterns, the more that we can make performance last. Another very quick optimization that we do is that on the background, we automatically switch all of our clicks to touch start. That means that developers can still be writing click, and automatically when users go to our sites on mobile devices, it feels up to 100 milliseconds faster because everything reacts on a touch start, which is when you press down, versus a click, which fires when you press up. And now, I did mention the number 100 milliseconds, which is very minimal. So developers usually ask, is it worth it? Do I need to go back and fix my code in order to achieve this? So we drafted 3 different questions to when performance should block the development. And is it part of the critical path? And what I mean by this is, whatever code you're writing, is it happening? Is it executing while the page is still loading? And if the answer is yes, you should address performance. How frequent will it run? Do you have something that you are getting from a data and you're running a loop? You don't know how big that data will be. So your loop, whatever you're doing in that loop, should be as performant as possible. But this also addresses having an interactive component. For example, a date picker. I'm friends with people that work on airline websites. And you know that when you're trying to buy tickets and you are not sure if you should fly the Thursday or the Friday, you keep checking and clicking around. And if that element is not responsive fast enough, you're going to get frustrated. And the bigger question that is not measurable is it a shared or a base component? And what do I mean by this? When developers write things, they tend to get really focused on just writing that code that fixes that specific feature. But we have to know that whatever you're thinking that is only addressing one thing is going to be seen by other developers as a pattern, as something that can be reused and extended. So we need to think of whatever code that we're writing as what else could be done through this code as we're putting it in. And all of this, let me see that we're really planning for today's problems. We're building features, we're building a code that addresses today's features, and we're not really thinking, where do those features go? So how can we prevent from blocking ourselves tomorrow? Which led me to a third path that is usually not talked about, of product and design. This is our life cycle. Someone has an idea, then we build a prototype, then we test that prototype. If it's successful, it goes into development. Then we determine a minimum viable product. What is the minimum thing that this feature needs to do in order to be successful? And then we optimize. Now, in most companies, this is where performance happens. We wait until there's a problem, until something is noticeably slow, and then we fix it. And initially, this is where I thought that performance should happen, because anything before here is not real. Like, we're just experimenting and we're testing. But then I found this is where it should happen. And there are a couple of reasons why. For us, we were building prototypes so fast that we're successful and people like them, and then it would go into actual development. And because the prototype was built so fast and so hacky, it just took so much longer to build the actual real version that non-technical people in leadership felt confused. Like, I just saw this, like I was playing with this. Why are you telling me that now I have to wait a month or 3 months to see it actually live? So that was one problem. But another problem is that since here, we were only asking the questions of what this feature does. We were not asking, how could this be reused by something else, right? And the question that I found that was the most helpful is asking ourselves, whatever we're building, what if it runs? What if it's amazing? What if it ends up being the most popular thing for revenue for the product? How do you see that feature growing if it is successful? And asking those questions helps us address from the code, from the very beginning, how would that code grow as that feature becomes more popular? It lets us draft performance paths. We ask, why are we doing this? What is the goal of doing this? We can align best practices with goals, and we're able to say, if we're doing something for SEO, we should watch out how the render time is affected. Or if we're doing something interactive, we can look at the runtime performance. And we also can compare mobile versus desktop. Desktop devices have more of a performance capability. So together, without addressing performance that much, test it first on desktop, and then later you can move it down to mobile if it was successful, and add all of those performance optimizations. And we document our trade-offs. We can specify the reasons when you make a trade-off, you're making a trade-off either if you know or you don't. We make trade-offs every day, and the more that we try to know what the trade-off is, the better we're going to be. So if we document it and we ask ourselves, what are the trade-offs that we're making, and is it by design? We're making that trade-off of not adding a library because we are making that decision today. Or is it a technical limitation? Is it something that you wanted to do? For example, you wanted to use web workers, but worker DOM is still on alpha, so you're able to document that, and when worker DOM is out of alpha, you can do a search on your documentation and go back and see, hey guys, we can actually fix this now. And having that documentation lets you plan them. Something really helpful for non-technical people is to describe the scenario that a trade-off would block. If you tell them, hey, if you envision this feature eventually being able to do this, if we don't do this right now, it's going to be much harder to do that later. That's a really helpful example to show to leadership of why we should address something today. And overall, it just really prevents told you so moments between coworkers. No one likes being told, hey, I told you that if we didn't do that, it was going to be bad. See, I was right. No one likes being told that. So the more that you just document it, the more that you prevent people from really getting their feelings hurt, because it was on paper, we agreed on it, and it's there. But the bigger question that I wanted to answer today was, how do we stay fast? Performance budgets are great, but it's rarely a single pull request, right? Like our problem was we have developers adding 3 kilobytes of JavaScript, and they say, well, it's fine, right? But then you add all those up, and it ends up being 300 kilobytes at the end of the week. So I thought about how can we predict regressions? And I built this tool called Spotter a while ago that it has nothing to do with performance. It just tells you if there are any other open pull requests that are working on your same files. And I thought, how can we use that and start integrating on our CI? So I thought about Spotter CI. And what it does is that daily at a given time, so for us it's 8 a.m., it goes and collects all of the open pull requests that have a ready to merge label, for example. And what it does, it merges them into a temporary branch, and it opens up a pull request and assigns any users that you have given it to a configuration. That means that at 8 a.m. every morning, I can answer the question, how bad is performance if all of those pull requests are merged today? But there was a problem. There was no tool out there that would give me the consolidated performance on a pull request. So all of them, all of the tools that I tried had problems. Had a single URL, it ran and blocked the build process, and it had no consolidated reports. So what to do? Well, I built one. So I'm happy to introduce this tool that I released this week. It's called Lightkeeper, and it lets you maintain liveness budgets in pull request URLs. The way that it works, it runs after your CI. Who here uses GitHub? And who here uses any of these tools? And if you don't use any of these tools, you can use any GitHub check run deployment or status. Pretty much anything that shows here, Lightkeeper can run after that. So if you have anything in Jenkins or something else that is creating a pull request URL, Lightkeeper is going to run after that. It has a flexible configuration where you can say performance scores, and Light Wallet, which was introduced this year by Google. So you can set budgets on your script for third party, and routes for homepage articles. And you can customize the settings per route. And this is a really custom one. You can customize everything, even the Lighthouse settings. So you can load one URL on desktop and one URL on mobile if you wish so. And this is how it looks. It tells you all the errors that we found across all the URLs, and it has drop downs, so you can go deep as much as you want. It also has warnings, so you can get on top of refactoring. And this is how it looks with performance budgets. It can tell you how much over budget you are, over resource counts or resource scripts. And this is the only comment that it has. It has a consolidated report that has warnings, and errors. And if you have improvements, you see those at the top. So that way, if a developer is accidentally making an improvement, they're able to see it right away. And so try it out. Here's the link. I'm more than happy to hear what you think of it. It's pretty early, like I said, I released it this week. So I'm more happy to see if you have any ideas or you would like to see any other features added to it. And the main reason why I'm building this tool is because I think that performance culture is more than code. You can have the slowest site or the fastest site. That doesn't mean that you have or don't have performance culture. Because it's not about fast or slow, but the choice to wander out and tackle priorities that you might have on your business, but to have a clear path back to where the site should be. Thank you so much for listening. I'm on Twitter. If you want to follow Lightkeeper or Spotter CI, which I'm currently building, this is the URL if you want to see this deck and all the URLs on Glitch for the code. And that's it. I'm going to be at the speaker corner or at the party. Just come grab me. I have Lightkeeper stickers.
Yeah, who would like to take more stickers about Lightkeeper, please find Freda in speaker's corner. And thank you again. Ребята, сейчас давайте сделаем 5 минут перерыв и поехали дальше.
сказали, что они ставят. А вещи? Катя, а вещи? Там нет ничего такого?
Я типа телефон забрала. That's it. Yeah.
Do you know something about PWA? Who worked with PWA? Who reads standards? So, right now we will discuss very interesting topic about PWA. It will be collaboration of tech topic and business topic, something like that. So, Jamie Maria will prepare PWA topic, and let's let.
I think someone has a question. Yeah. Oh, this is very dark. Yeah. Okay, guys. I know it's the last talk of the day, so you're probably tired, and I can see the room. Also, not so many people. Probably everybody's waiting for the after party. But I promise you, I'm gonna make it fun today for you. So, first of all, I'm gonna quickly introduce myself. So this is my face, and easy, right? That's my name, Jamie Maria Schouwer. You can forget about the last part because it's really difficult to pronounce. I'm a co-founder of the company called Deity. We're based in the Netherlands, and this is my Twitter handler. Please follow us so you can see what we're doing. So I have another small announcement, and actually I'm very happy to share with you that yesterday it was my birthday. So I was 29 yesterday. So I'm happy to share some drinks with you tonight and celebrate my birthday here in Odessa. Who knows this screen? Okay, tell me. Yes, indeed. It's the Back to the Future console, and what it says is that on the top it was the destination time, April 23, 2018, which means that at the moment we should be in the future, right? Because they went to the future, which was about 1 year ago. And if I look at the movie, I can actually see that they were quite right about it. Because when I see what they predicted, they said we would have self-lacing shoes. And we actually got them. They also told us that we would have some kind of tablets that we can use as a computer, and of course we got them as well. They predicted in the movie that we would have a hovercraft kind of board, and they also predicted that there is some kind of device out there where you can do this with, but obviously the biggest trend of 2018 was this thing. And I think it comes pretty close to the hoverboard. Then they told us you will have glasses which are computers. And we also got them. They predicted even that we would be able to do video chats and video calling. And of course, we all know this from Skype and all the other tools that we have them. But one thing I'm 100% sure that they predicted right, that today is the future, is that they also predicted who would be the supervillain. And the supervillain would be a blonde guy living in a tower. And I think they also predicted him very right. So basically, that means that the future is now, right? They said the future is now, it should be now, but is it really? Because if I look at the state of the web in 2018, 2019, this is what we have. Websites loading, asking to send us stuff, asking to send us more stuff, asking us if we agree with privacy and if we're over 18, and it doesn't matter whatever I fill in, 1299, I'm still going to be fine. Do I live here? Is this my city? Do I want to have a newsletter? When I'm finally there, some chat pops up, asking me if I'm having an ad blocker, and did I find what I was looking for, and no, website is not loading. But maybe I want to share it on social media. And I'm very sad that this is the state of the web, because we have 5 billion devices connected to the internet today. And it's growing, this number is growing. And these are not just tablets and phones and laptops, these are also fridges and washing machines and all this kind of other stuff that we have around us that is connected. And if I look at how we use devices, this is a very interesting chart. So you see the green line going up and you see a blue line going down. And the blue line is desktop and the green line is mobile. And it's somewhere in 2017, it started started to collide, and it's almost similar now. Which basically tells me that we're using both devices. They're equal. People have a phone and a desktop, and this is what we use. So we should focus a little bit more on that. And specifically, if I look at how we use devices, and this is some chart from Facebook, and it's saying, okay, we have 94% people are using mobile, but 62% of people are accessing the internet mobile only. So why are we still bothered about desktops? And if we have mobile only, we should really focus on that, but mobile websites tend to show us this. Load times. And especially if I look at some numbers, we can see that 53% of users are leaving websites after a 3 seconds load time. And if you're doing e-commerce, then you will know that 1 second delay with a shop that 100K turnover a day is losing €2.5 million. 1 second a day. 1 second load time, 2.5 million in a year. So we're talking about 3 seconds, 4 seconds, 5 seconds, but does anybody know what is the average loading time of a mobile device in a 3G network? Can you take a guess? Show the number, how many seconds? 10 seconds, you think 10? Who thinks more? Who thinks less? No hands, so what do you think? 10 is right, 1 hand. Well actually, it's going to be very surprising to you that the average loading time is 19. And a 4G network is not much better, it's 14. This is the web. So, we are developers and obviously we know how to do stuff, so we said we can fix this, right? We're going to fix this and we're going to do that. And we did that in 2009 with something called HTML5. You probably all remember, and there were some big companies like this guy who said, let's do this. Let's go to the HTML5. So what did they do? In 2012, they released the Facebook Hybrid app. And did anybody of you use this? I think probably some people will, because actually it was the most downloaded app ever. And the funny thing is, it was also the baddest one. It had 1.4 million reviews, or more than 1 million reviews on 1.4 rating. And then the guy said, well, the biggest mistake we've made as a company was betting too much on HTML5 as opposed to native. So this is also the time that we all said, let's go to native. Let's go to native 2012, let's build native apps. And it had a lot of advantages, it still has. It has advantages in performance, it has advantages in smooth animations and interactions, instant loading, and you can even show some stuff offline. You have easy access to the home screen and a super high engagement. And if we look at the numbers on how we use our phones, we also see that 87% of our time we're actually spending in these native apps. So why is this talk about progressive web apps? Because people are using native apps so much. Well, that is because apps are very highly concentrated. And actually, app usage is just 80% of the time we spend on 3 apps. And that's mainly social media, Facebook or something, and you're using some messenger app and maybe some news app. These are the top 3 apps that people are using. And do you know what is the average amount of apps that are being downloaded per user per month? Can anybody guess a number? 2? You think 2? Somebody thinks more? 50? Average? 5. 1. Well, you're going to be very surprised, because it's 0. Oh wait, 1 back. Actually, 0, yeah. So why don't we download apps? Well, that's because apps have a lot of disadvantages. And one of the disadvantages is the distribution problems. Because yeah, you have to guide people through the app. You cannot really distribute it very easily. Updating is a pain, because people also have to update you. Application size and memory usage is very difficult. You have different operating systems. If I have a website and native apps, I'm building 3 systems. I'm building a responsive website, I'm building an iOS app, and I'm building an Android app. 3 systems to maintain and 3 systems to build. And there's a 10% revenue to the App Store. And actually, the iOS App Store has a 30% Apple tax. 30% of your revenue is going to Apple. And we don't really want that, but we work hard for our money, we want to get the money that we earn. So, this is where I call it the search for appiness started. Because we wanted to have the experience of an app, but we didn't want to have the disadvantages of the app. And with happiness, I mean it's the same experience in the web browser, but then really mimicking what's happening in native apps on a smartphone. And the search for happiness started with all kind of these initiatives. And maybe some of you use this kind of stuff. There's Chrome apps, Oxford Project, there's some BlackBerry even jumped in. But they all kind of failed. And most of them failed because they're not linkable. You cannot link to them. Which, in my opinion, if you cannot link to your content, then are you really part of the internet then? If you cannot guide people organically to your content. So finally, in 2016, the web strikes back, right? So we finally have a solution for this. And there was a company called Google, and they came up with this concept called AMP. Do you know about AMP? Yeah, it's called Accelerated Mobile Pages. So what do accelerated mobile pages do? They can very fast load pages. And the Weather Channel used this, and they had on the 1 second page load 10 times less data, instant access to information, and a 4 times higher click-through rate. But the problem is here, they're not dynamic. These pages are static, these are landing pages, and you cannot really do anything with it in e-commerce or when you want to show some personalization or very dynamic data. So then Google went back to the drawing table and they got very creative because they said, let's turn this around and make AMP into PWA. So what is the main difference between these two things? Well, actually, we have AMP, fast landing pages, and then we have PWA, which is happiness. Because PWA actually merges the best of two worlds. So we have, I'm not sure if people in the back can read this, but you have native apps who can do certain things and who cannot do certain things. And there is responsive websites who can do certain things and cannot do other things, and then progressive web app can do all. So we're talking about functioning offline, sending push notifications, installable on home screen, full screen experience. It can be indexed by search engines. There's one place to enter your content and one place to maintain. It works across all the devices. You don't need to do a download, and it doesn't require updates because we update from the server, so the user doesn't have to do an update. So what is the progressive web app then? Well, you can break it down in three things. The progressive web app is fast, it's reliable, and it's engaging. And what do we mean with that? When we look at speed, fast, here is a project of the Washington Post, and on the left side you're going to see the instant mobile web, instant speed, and on the right side is the current mobile web. And this company is, I think, spending quite a lot of money in doing this kind of stuff, so they're pretty good. So I'm going to play it, and you're going to see, watch it, don't blink, it's very fast. Left side is done. And the right side is done now. 3.3 seconds, it's a fast website, versus 0.9. And what is the main difference between these two? On the right side, it's just a very fast website. And if I click through to another page, the page is going to have to load again. You're going to get a similar loading time. On the left side, everything is now on my device. Everything is there. So as soon as I click again, or I go offline, or lose connection, or whatever is happening, the page is loading even faster than before. Because everything is already there. And that is what we talk about when we talk about instant speed and basically caching. So Tinder also did this. You probably know this company, and they turned the thing into a progressive web app, and they have now 7.2 seconds faster, 90% smaller, more messages, more swipes, and longer sessions. Just by improving to a progressive web app. So, next thing I want to show you is about engagement. So what actually is engagement? And one of the most things we know about engagement is push notifications, right? So when we talk about, you can do push notifications from websites, there's e-commerce companies coming up and saying, well, this is so cool, you can start sending all kind of advertisement. But obviously nobody's going to press the button next here. Nobody's going to do that, everybody's going to press the cross because we have enough advertisement. But using progressive web app technology, you can actually have access to information on the device. So for example, you can have things like location, and you can know where someone went before, this kind of stuff. So you can send very, very engaging messages to someone which do work. For example, this. It says in the text, get your groove on, 25% off cocktails all weekend at the Fizzle nightclub. Because I know I've been there, I know you're still in the neighborhood, and I know I love cats. And these kind of things have a very high click-through rate. They have about, if you compare it to email has about 2%, 3% click-through rates. These go up to 10, 20% click-through rates if you do it right. I mean, this is the kind of engagement that we want, right? So Lancome company did it. They have 53% increase in mobile sessions on iOS, 8% percentages coming from push notifications, and with that they're able to 12% recover the cart. By just sending a push notification, there is stuff still in your cart. And the very interesting about this case is that actually push notifications are not allowed on iOS devices. So the push notifications are only being sent to Android devices. And then if you look at the data and the users going to this website, 62% of them are iOS users. So they're able, just by a very small part of the audience, they're still able to get 8% more purchases there. Very high revenue growth there. So talking about offline and online, who remembers this device? This device, ooh, it's very wide now. Can you see it actually? No, it's the thing is a little bit off. Well, it's fax modem, 56K fax modem. Does anybody remember what it was? Yeah, tell us. Yeah, it was for the internet. And do you remember the noise it made? Yeah? Because this thing was taking us online. And you knew if you were online. Because first of all, you could hear it. The thing was making a very specific noise. But also, nobody could pick up the phone. Because if somebody would pick up the phone, your internet was dead. So going online back then was really an experience. You know, you were going online. And that's something we don't know today anymore. We expect to be online all the time. So we don't go online anymore, we're always online. And progressive web apps can actually help with that. Because progressive web apps make sure that even if you have a bad connection, even if your internet is falling down all the time, you can still serve the content to your users. Uber did this. And Uber were able to load within 3 seconds on 2G. And they were not able to do that before without a progressive web app. So that means that they fully opened a new market. Because they finally can serve their product to a market which has 2G, and there's quite a lot of that in the world. So for them, this was a huge business opportunity to do this. So, but what actually is a progressive web app? So a progressive web app is, according to our friends from Google, they say it's a whole lot of things. So progressive web app is progressive, it's responsive, it's connectivity independent, it's app-like, it's fresh, it's safe, it's discoverable, re-engageable, installable, and linkable. Yeah. Well, what is it? So, technically speaking, a progressive web app from the tech side are basically 3 things. It's a website served over HTTPS. There's a service worker, and there's a web app manifest. That's it. And I don't really have to explain you about what HTTPS is, I think, so I'm going to skip that part, but I'm going to explain you the rest. So, a web app manifest, first of all, and probably you cannot see this code there, a web app manifest is basically just a text file, a JSON file, with some metadata in there. It's telling us what is the theme color, what is the icon, the background color, and the name for my progressive app. And this file makes sure that I can be added to a home screen. Because I'm telling the device, and I'm telling the browser, so what is in this home screen? You know, what should I show, and what should I look like if someone opens me from the home screen? If I'm installed, what is the icon? When I open it, what is the splash screen? That's it. One JSON file, and you're installable on the home screen. So it actually looks like this. So here is a website, and here this is an Android device, and then it recognizes that that it has this file, web app manifest, and then it's asking me, hey, do you want to add this to your home screen? I click, done. No app store in between, and I'm installed on the home screen immediately. Very, very easy path to guide your people to use your device. iOS also does it. It has one step in between. You can try it, and there you have to click the button and physically add it to the home screen, and it's there. Pop again. No interference of any app store here, and still it really acts like an app. So when I open it, it's not a browser shortcut. So you can try it with some websites, and you will see the difference, because you're going to find some websites who still just have the browser shortcut, and you're going to find some websites that actually open like an app. So Flipkart did this, and when they did it, they had 70% more conversion. 70%. That's a big number. 3 times less data usage. So it's also a big number for them, right? Trivago did it as well. 150% growth of engagement from the add-to-home screen users, and they almost doubled their conversion rates. These are big numbers, just by adding this file. So there's another thing to progressive web apps, it's called service workers. And does anybody know about service worker? Are there people who know about service workers here? Some people? Good, some more people. Okay, I'm going to explain you a little bit, walk through very quickly what it is. Basically, a service worker is a client-side JavaScript proxy. I mean, that's quite a handful. And what it does is you can use it to improve performance, make your app offline first. It's the base for very advanced features like push notifications and stuff. So it basically works like this. So I have my device on the left. There is a service worker in between me and the web server. So the first time I hit, the service worker will get installed. And then the second time I come, or when I go to another page, the service worker is saying, hey, is there something new? Yes, then I'm going to send you to the server. If there's something not new and the website is still the same, I'm going to show you the cache. So this also means you can go offline. Because if the web server is not connecting with your device, you can still get all the stuff that you need. What the things actually we as developers have put in that cache. And I can deliver super high performance here. So how does it basically work? Service workers have a life cycle, and they have a registration, they have an installation, and an activation. So when there is no service worker, the thing is getting installed and it's getting activated, and then there's this thing happening. So every single time I go back and there is a 1 byte difference, it's going to reinstall, and if not, it's just going to keep the way it was before. So how does this work? So the registration, and I think it's really hard to see from the back these codes, but basically here it says, hey, is there a service worker? Is it already installed? Yes or no? Is there a difference? Yes or no? Then I'm going to install it. And it's really fast, you don't see it as a user, you don't feel any delay there, there's nothing happening there. Here's the installation, so it says it calls the event, okay, perform the task and do give me the thing. And actually the funny thing is you can, during the installation and during this activation part here, you can already do everything. So you can send all this stuff, the whole cache is there now. So it's actually super fast immediately in there. So what if you want to use this to do send push notifications? Well, basically it works like this. So you have your server, then you have a web push protocol request. It's talking to a push service, and that one is talking to the service worker on the device. And basically what you do, you call two APIs, the notification API and the push API. And why are there two? That's mainly because the push API makes sure that the messages arrives on your device if your browser is closed. Even closed in the background, you can still get the messages there. So also when I send out a message, now a push notification, and someone has a whole phone off and they turn it on again, they can still arrive there because it's waiting with the service worker to come. So what I first do, when I want to do this, I need to ask for permission, obviously, because we cannot start spamming everyone. That would be very fun, but also not fun. So I ask for permission, and it's checking if I already gave permission. And the funny thing is, you only have to ask permission once. So the browser just has to ask permission once, and it's just one press of a button, yes or no. So when I do that, the permission is granted, and the device gets registered. So the push, the device gets registered with the service worker. And this service worker is registering with our push API. So that also means that I don't know what this device is. So it's super safe. There is very GDPR proof, because I don't know the name of this device, I just get like a code there. It looks something like this. When I start then sending a push notification, I have my body, I can send an icon, and you can even send things like vibrating patterns. So you can even make your push notification very special and give it a special vibration. 100 milliseconds off, 50 on, and 100 off. You can do some crazy stuff there to really make people aware that it's you. And then obviously there is a data and there's a primary key there, because I need to know if someone opened it or not, without knowing the actual device and without knowing if someone is who that is. And obviously there is my stuff saying, hey, what do I want to show there? Hello world. So it will look something like this on the browser. Obviously on the phone it will look exactly as a push notification on the phone. And what you see here is that I can add buttons there. And the funny thing is I can actually add buttons which are different from the actual push notification location. So for example, I have a shop selling cars, and someone has been looking at the cars all the time, and then I have this car again, and I'm sending them, hey, here is the car again. But the car is black, and I can add a button saying, do you prefer a red car? Click here. So I can really get a very nice interaction with my customers there. So here are the actions. Obviously there goes the actions. So I have the explore, you go to the site, or I have no thank you, then I have no thank you. So I know what is happening on that site. So I get something back, like for example notification close or click, obviously. And I can do stuff with that data because I can calculate what was the click-through rate here. The only tricky part about this is you have to actually close the notification. So if someone does a bulk close of notifications, then it doesn't register as closed. Someone actually has to close that specific notification for me to register it. So the clicking, yeah, it's very simple. It goes like this. There is an event. Hey, this event, it says action, close, it's closed, thank you, and close the window, or go to the specific page that I recommended to go. So how does it work on the other side? So we're sending and receiving these push notifications. Well, it looks like this. So I have my server, and I'm sending it to the push subscription endpoint and server, which is in the browser, and that one is connecting to the device there. So if I just look at this push subscription endpoint, it's telling me, hey, here is this. I have to check is there registration, yes or no, because I'm sending this to everyone. Very different from email marketing where you send to a specific list. I'm actually sending this to everyone, and then the service worker is saying, am I registered, or do I have these kind of things that you send me, like I only want to send to people in Amsterdam, do I, yes or no? So the service worker is dividing if I'm in that group or not. So here is that you send it to the endpoint, and this endpoint is from a Google browser, from Chrome, and obviously there's the keys there, so I know it's safe. So here goes my server, and on my server this is what I write. So this is in Node, and I write basically, here is the push notification, here is the API key where it's going to, and there is a time to deliver. Because obviously you don't want to send a push notification with a flash sale and then have people arriving it like 3 days later, because that doesn't make sense, so you can set a time to deliver that. So here, and there is some icons there, but they're very white out, so I'm not sure why you cannot see them. So there's only the black one there, because that is the service worker there saying yes or no, allow me to the device. So basically it looks like this in a very schematic overview. In the browser, the push arrives, the service worker starts, it handles the message or not, and then it shows the notification. And when it shows the notification, you can get stuff like this. And we can be all very happy that this is appearing on our phones. So, if I break it down again, we have 3 things to add, right, to be a progressive web app. We have a service worker, we have to be HTTPS, and we have to be a web app manifest. That means that literally any website can be a progressive web app, right? Just add these things. Well, that's not really true, because progressive web apps are about the web being done right. It's really about user experience. It's about engagement, and it's about giving the same experience as we have with native apps from the web. And with doing right, I mean projects like this. Webshop.nl is a Dutch web shop. It's a very easy name to remember. We built this. It has 7 million products on live, 19 million tested, and it was built in just 2 months. And it has an instant search there. And I'm going to show you what I mean with instant. You can see this video. I'm typing here Lego. And as you can see, it's searching in 8 million products on this version. Lego green. Can click, it's showing some things where I can actually buy it. It's kind of a price comparison website. And then I can even go back and I type here dress and whatever. But the funny thing is, if you see them appearing, the images, there is like a small delay because you see a little bit of white and then you see the images. And we actually built that. Because the images were appearing, the products were appearing immediately, and people didn't see that something was changing. And you can see it and you can test it easily, because in the top, when I'm typing, in the top, and you cannot see it here, but try it, every single time I hit a key, it's appearing in the URL. And the image is actually appearing a little bit later, because we deliberately made it a little bit less fast. Because people are not really used to that. So PWA is not just about being the fastest thing out there, it's really about giving the right experience to your customers. So another one we did is called The Rake. It's a magazine in the UK. And it had 80% growth in organic traffic. Instant loading, but it has something else. It has a headless architecture. So it's more than just a PWA. And what I mean with that is that this magazine, so you can see it's quite fancy, so they came to us and they said, we want to have a content-driven web shop. And we want to use Magento, and we want to use WordPress at the exact same time. Can you please merge these two? And we were like, Yeah, we can, but we won't. Because if I do it, it's going to be fine, and you can work with it, but you can never change anything. It's going to be a hell of a job to maintain, and it's going to be a hell of a job to change something. Because if you want to replace WordPress at some time, or want to add some module in there, you're going to have a problem. So what we did, we made it headless. So we turned it into a headless web shop by having the front end, then an API layer there, and there is the back end. The front end is built in React, then the API layer, basically the service layer, has been built with Node.js and GraphQL in there now, and there's the back end. But the back end is not just one back end, because the back ends are more things. So the backend can be Magento. It can be Algolia at the same time. There is WordPress in there. There is PayPal, and there's Akinio in there. And all these things are working separately. They're not integrated with each other. So the front end knows where do I need to get this data and to pull it up. That also makes it easy not only to maintain and to extend, but it also makes it very easy if you want to switch something out. So if at some point they say, hey, we want to get rid of WordPress, we don't like it anymore, they want to have type 3 in there, we can actually do this. If it was tightly coupled, we have no way of doing that. I mean, we could, but it would take, rebuilding a whole new project there. But actually in this way, you can very easily do it because you just switch out the API. So what are the results of this kind of stuff when you build this? Well, it's this. 100 Lighthouse course. And why is it so fast? It's so fast because we're using a React.js framework on the front. Then we have a Node.js server taking really care of things like caching and such. And it's a single page application. And the last one is a very tricky one because you can build very nice single page applications, but Google will not see you. So you need to make sure that you're using things like server-side rendering there, or else you're going to have a problem and you're still not linkable. So after launching this project, we had many people who were like, what did you do and how can we use it? So we decided to open source it. And the project is called DatiFalcon. And basically what DatiFalcon is, it's a developer toolkit to create progressive web apps. It's platform agnostic, it's extensible, and you can build any type of website. So not just e-commerce, but you can do blogs, you can do whatever you want to do with it. There's a GitHub link, and please visit, give some stars and stuff so we can move forward. Pictures done? Yes? Good. I have some flyers here as well with the information on, so please take some. So to show you how this looks like behind the scenes, here is the drawing of the architecture, and you cannot read this in the back specifically, but on the top, it's basically two products. Because on the top there is a Falcon client, and this is the UI layer. And this is built in React, but it can be anything you want to use. You can add Gatsby, or you can use Vue.js, it doesn't matter. And then the magic happens in the Falcon server. So this is where we use, for example, Apollo, there's proxy there, we do caching there, and we have an extension layer. And this extension layer is saying, hey, is this a block, is this dynamic, is this a shop? So you can use all these different tools at the same time. Then underneath, you can start adding APIs from whatever service you want to use. So we have GraphQL in there, so you can use Magento and connect it to Magento, or BigCommerce, or WordPress, or Algolia, or Elastic. You can use whatever you want to use there. So this is the main architecture, and we specifically build this to be able to give people the option to really make it extensible. So we didn't want to build a very fast team. We really want to build a toolkit so you can actually do stuff yourself and build it and use it for any project you wanted to use. And actually, I think we're on a good way, but we still have some way to go. Because according to Gartner, by 2020, 50% of the web needs to be replaced, general apps need to be replaced by progressive web apps. 50% in 1 year, we have 1 year to go. And I think we're way behind. So we made it even easier for you to start, and we launched this thing, so within 3 steps in NPM, with this 3 code lines you can actually start. So when you do this, on your screen will pop up the basic Falcon. There will be a Magento server and a WordPress server, so you can start playing around, switching out, and do whatever you want to do with it. So please give it a try, 5 minutes, you have it up and running, and you're gonna have a store with 100 Lighthouse scores there. So before I end this presentation, we can all move on to have some drinks. There's one last thing I want to share with you. And that is the fact that progressive web apps are not new. It's not something Google invented. It's not something we just came up with. Because actually, in 2007, Steve Jobs presented the very first iPhone. And what he says this is an innovative new way to create applications for mobile devices. And he gave us a list. And he said, it's Web 2.0, it integrates with iPhone services, it has instant distribution, it's easy to update, it's secure, and it's sandboxed. And this is a definition of a progressive web app. This is it. But why didn't it go through in 2007? Does anybody know why it never happened? And why we're doing it now? And also why Apple is actually now trying to hold back and not allowing all the features? Does anybody know?
App Store?
Correct. 1 year later, they launched the App Store. And this is where they make their famous 30% Apple tax. Thank you everyone for my presentation, and I have some stickers, I have some flyers, so please ask any question you want. No questions? Oh yeah, we will have to do questions later, right?
Yeah. But I don't know. I think we can ask a few questions. Because we are waiting our sponsors.
There are questions? Yeah, good.
Thank you very much. Ultimately, could you please refine, does web app have future to replace native?
Can you move the microphone a little bit closer?
Sorry. Does web app has a future to replace native apps?
If I think that progressive web apps are going to replace native apps? Yeah, I think so. I really think so. I think for this is the new responsive, this is the new web standards. Eventually they're going to replace them all. Because why would you still build several systems where you can use one? Why would you get through all this process with App Store and updating and all this stuff if you don't need to anymore? I cannot, I mean, there might be some very specific use cases, like for example, games or something, you know, you really want to play. But I still think in the future, when this technology is more involved, and you know, that's why it's called progressive, because we can add things in the time. I think that eventually there's no need anymore to really have native stuff there.
How we can describe this thing when you have developed platforms like Flutter and React Native? Is it competitors for web apps, or?
I'm not sure if I understand the question. Can you? It's a little bit noisy here with the door. I'm sorry.
In this case, how we can describe development of such platforms like the Flutter and React Native? They provide the cross-platform experience, and in the same way, according to your work, as I understood, we have a software like a web apps, for native web apps, right?
Yeah.
So in future it will be on the same level on a competition, but because now I don't think so. It has same level of developing native-like application.
Well, it's depending on a use case. It depends, what do you want to build and what is the use case for that. And you can use, for example, our technology, but our technology is not the only one, you can use to build this kind of standards, right? So you can use the technology that fits your application. And if at this moment you really need a native app for whatever reason, you're gonna have to use that at the moment. But I do think in the future, a few years ago we were doing separate mobile webs and separate desktop websites, right? We were doing both. And there were many people then saying, yeah, why should we go to responsive? It's just complicated, and then you need to figure out what is the screen size before I can send some stuff and that kind of stuff. And there were still companies really trying to get to, you need to add mobile dot and then my website to get the right thing there. But this eventually also evolved, and this technology evolved, and we got different screen sizes, so we couldn't build like 5 things because tablets came, and then we had to build specific for mobile, specific for tablets, specific for that. And this is just a natural progression into what the web is moving to make it easier, to make it simpler, and to merge these technologies.
Thank you.
Thank you. I think that's all, because second stage will finish.
Okay.
So, thank you so much, Jamie Marie. Далі я переключусь на українську. Української мало на конференції, української найменше на конференції. Тому